What's up guys, welcome back to the channel. Today, as you can see on this video, we'll be solving this previous question paper that you see here. As you can see, this is a mathematics N4 previous question paper, which was actually written on the 20th of November 2024. It was an X paper and it took about 3 hours to be written. Now on this video, we're gonna start with question 1, and then we do question 2, question 3, question 4, and question 5. So I'm gonna leave the timestamps so that you can able to watch the specific question that you would like to watch, just in case you don't want to watch these videos in a sequence order. Now before I start though, I'd just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because I've done lots and lots of videos based on mathematics and also previous question papers like this one. Now let's look at question 1 and let's see if we can able to solve it. Right guys, as you can see, here's our question 1. So question 1 consists of 1.1, 1.2.1, 1.2.2, and 1.3. So it actually has 1, 2, 3, 4 questions. Now we're gonna start with this one here, which is 1.1, where they want us to draw this neat graph of y is equaling to 2e to the power of 3x. So I'm gonna copy this question and I'm gonna paste it where there's space and we start solving it. All right guys, as you can see, here is our 1.1. Now they state that we should draw a neat graph of y is equaling to 2e to the power of 3x. Now as you can see, this graph here is an exponential graph because our x is an exponent. So now how do you draw an exponential graph? The easiest way of drawing an exponential graph is to use the table method. Now I'm gonna draw the table here and insert the values for x so that we can get the values for y. Alright guys, as you can see, this is our table. Now it's time for me to insert the x values. Now you can insert negative x values and positive x values. Don't forget to also insert 0. I would say to you guys, don't insert big numbers because we have the x coefficient there, which is 3. If you insert big numbers, you will get very huge numbers for y. But you can insert any number as long as you understand how to draw this graph. So I'm going to use negative 0, 2 for x and also negative 0, 1 on the negative axis of x, then it's 0. And in the positive, I'm just going to use 0, 1 and 0, 2 on the x-axis. Now on the y-axis, it will depend when I substitute our x, what is going to be our value. Remember guys, you can use any number as long as you can able to draw. So I would say to you, use the smaller numbers for x so that your graph cannot be big or give you big y values. All right, let's start substituting. So wherever there is x, we're going to substitute with the x values in the table there. Now let's start when x is negative 0, 2. Now if you punch this on the calculator, your answer is going to be 1, 1. So meaning when x is negative 0, 2, your y is 1, y. And then let's put another value there. Now when x is negative 0, 1, what is our y? Now our y is going to be 1, 5 approximately, right? Now when it's 0, our y is going to be 2. There we go. Now what about when it's 0, 1, the positive side? Our y is going to be approximately 2, 7. When it's 0, 2, our y is going to be 3, 6. So this is basically what our table look like. So we're going to use the values on this table to draw our exponential graph. So let me first draw the Cartesian plane and let's start plotting the graph. All right, as you can see here, guys, we have the following values on our Cartesian plane. Now it's time for us to just plot the graph. So let's start with the first point here, where x is negative 0,2, which is this one here. You just take a ruler, you draw a vertical line like that, where x is negative 0,2. What is your y? So your y is going to be 1.1. So we have 1 here. So above there, a little bit above there is going to be 1.1. So wherever they meet here, this is your point. Right. Now, what about the second point where x is negative 0,1? Now we know that x is negative 0,1 here. So you draw a line that is vertical to that point. All right, and then our y is going to be positive 1,5. So 1,5 is 1.5. So if we have 1 here, half is going to be between 2 and 1 on a y-axis. So you draw a line again as it touches this. This is your point there. Now when x is 0, remember x is 0 on a y-axis, and then y is going to be 2. So that is an intersection, which is 0 and 2. And then when x is positive 0,1, which is this side on the positive side of the x-axis, and then our y is going to be 2,7. Now, so 2,7, when you look on the y-axis, is going to be somewhere almost close to 3. So we can put it here, right? And then you do it then. So when our x is 0,2, our y is going to be 3,6. Let's look at x on the positive side on 0,2. Draw the line there, vertical to that. Obviously, you must use a ruler. And then your y is going to be 3,6. So if you look at y-axis on the positive side, 3 is our 3 here. 3,6 almost in the middle between 4 and 3. So you're going to lean more into 4. So you're going to be drawing a line like this, and then as it intersect there, this is going to be your point. Now, remember, the exponential graph, it looks like this, right? And the asymptote on x-axis, or it looks like that. As you can see, our graph here is going to asymptote on the negative side of x-axis. So you start connecting. Now let's start connecting. I am just going to do this. All right, guys, as you can see, this graph here, it has to asymptote on the negative side of x-axis, just in case you didn't know, right? It never, ever, ever crosses the x-axis. It asymptotes on it. On the positive side of axis, it grows. As you can see, it's going to grow and to infinity. So guys, basically, this is our graph here. But the most important things that you must show here is the intercept. So the intercept here, guys, it's actually 0 and our y is 2. So even if it didn't show these other points, as long as the graph has this shape and also you show this y-intercept, then you are correct for this graph. I hope you guys managed to understand how to draw this graph. Just in case you didn't understand, do not forget to leave a comment in the comment section. I'll try to answer you to my level best. But just in case you manage to understand how to draw this graph, you can always leave a like, and also if you haven't subscribed, subscribe to the channel. Right, guys, so we are done with question 1.1. We are going to do question 1.2. All right, guys, so let's look at 1.2. As you can see, 1.2 consists of two questions, which is 1.2.1, 1.2.2. So let's start with 1.2.1, where they want us to draw a neat graph of y is equal to negative 2 over 3 x minus 2. So I'm going to copy this question that you see here, paste it where there is space, and let's try to draw this graph. So guys, let's look at 1.2.1. As you can see, this here, guys, it's a graph of y is equal to negative 2 over 3 x minus 2. Guys, as you can see, this is actually the straight line graph. We have our y, we have our gradient, we have our x, and we also have our constant. Our gradient, which is negative 2 over 3, and our constant, which is -2. Now, guys, how do you draw a straight line graph? So the method that we're going to use here is the simplest method ever. You're going to use the intercept method, where we only find the intercept of the straight line graph. Remember, in order for you to draw a straight line graph, you just need to have 2 points. So those intercepts, they're going to give us 2 points, and then we connect, and then we have a straight line graph. So let's start. Whenever you use this method, you either make x or y 0. So let's start when x is equaling to 0. What is our y? All right. So when we use this method, we are basically saying that on the original equation, wherever there is x, we substitute with 0. So we know that y is equal to -2 over 3 multiplied by x. But wherever there is x, we substitute with 0 minus 2. Now, this is going to give us y is equaling to -2, because anything multiplied by 0, it's 0. So you're going to be left with -2. So we can say point A is 0 and y is -2. So we have 1 point. Now, the second point, we can also use the similar strategy, but this time we can say, let me just draw a line here. When y is 0, what is x? Right. So this time around, we make y 0. So wherever there is y on the original formula, we put 0 is equaling to -2 over 3x minus 2. So what we do here, we're going to transpose. So how about we transpose this term, -2 over 3 multiplied by x, to the left-hand side. Now, when you do that, when you take this to the left-hand side, this 2 is going to become positive over 3, and then x. All this is equaling to -2. Right. And then from here, what do? We multiply by 3 throughout to get rid of this 3 here. So if you multiply by 3 both sides, you're going to be left with 2x. And this side here, we're going to be left with -6. Then we start dividing by 2 throughout. If you divide by 2, this is going to be x. And that is going to be -3. So we can say point B is when x is -3, then y is going to be 0. So basically, these are the 2 points that we needed in order for us to draw the straight line graph. So let's draw the Cartesian plane and let's start plotting the graph. Right, so here is our Cartesian plane, guys. Please make sure that when you draw your Cartesian plane, you indicate your y and your x, and also show the negative side of the x and the negative side of y. Now let's look at point A. Point A states that when x is 0, y is -2. So x is 0 on the y-axis. So our y is going to be -2 here. There we go. And then point B state that when x is -3, y is 0. By the way, y is also 0 on the x-axis. So meaning our y is going to be here on the x-axis and our x is going to be -3. So from there, we just connect these 2 points. Right, so let's connect these 2 points, guys. Right, so here is our graph here. So you can name this graph y is equaling to -2 over 3x minus 2. So this is our straight line graph. Some of you guys don't like to draw this. It's fine as long as you show these points here. If you don't like to add these other points, as long as you show these points here, that this point here, which is point B, it's -3 and y is 0. And then here, and then -2. So you can also show that as well without showing these numbers here. It's still fine. But I would prefer you guys to draw everything so that everyone can see how do you get to this point. Guys, basically, this is how you draw the straight line graph. You only need 2 points. In this case, it's going to be point A and point B. And then from there, you just connect these 2 points and then you have your straight line graph. Guys, I hope you find it easy to draw the straight line graph. If it just so happen that you don't understand how I drew this graph, do not forget to leave a comment in the comment section. I'll try to help you to my level best. If it so happen that you manage to understand, or this helps you to understand, you can like the video. And if you haven't subscribed to the channel, subscribe to the channel. All right, guys, we are done with 1.2.1. Now it's time for us to do 1.2.2. So let's look at 1.2.2. What is it that they are asking for? The question is, the graph y is equal to negative 2 over 3x minus 2, a function or a relation. So you have to choose between the two. If this question is a continuation from question 1.2.1, this here, the one that we did earlier. So we need to go to the graph so that I can explain to you guys what is the relation and also what is a function. All right, guys. So with 1.2.2, they want us to find out what is a function and relation. I'll try to explain to my level best. Now, there are two ways of knowing how to distinguish between the two. So let's start with the function. A function, how do you identify whether a graph is a function or a relation? It's very simple. Now, let's start with the simplest strategy ever. One of the strategies or one of the methods that you can use to distinguish, it's when your graph, for example, we have an x-axis, we have a y-axis. It's when your graph cuts the y-intercept once. So as you can see, this is a straight line graph. How many times does it cut the y-intercept? Only once. So if it cuts the y-intercept once, it means it's a function. As you can see, this graph here only cuts here, guys, only here. It doesn't cut anywhere else. If you continue with this graph, it's going to cut them. Another example, let's use a parabola. For example, let's say we have a parabola that goes like this, right? As you can see, this parabola here, it only cuts this y-intercept once. Then it can continue and expand. It will never ever gonna cut anywhere else. So it cuts the y-intercept once. So when it's like that, this is a method that you can use to say this is a function, right? Now, another method that we're gonna use is gonna be, let me just erase here. Now, this method here that we're gonna use, guys, let me first draw the graph. This time, let's draw it this way, right? Another method is when you use the x value to find the y value. Now, if the x value gives you one value of y, then it's a function. Basically, if one x value gives you one y value, then it's a function. Here's what I mean. If we have, let's say this is 0.3 for x, and then if we draw a vertical line on any x value, but this time we're going to use 3, for example, we draw a vertical line there that passes on x. On the graph there, here, it's going to give us one y value. In this case, let's just say negative 2. Meaning now, 3, which is x, it's giving us negative 2. We call this method 1-to-1. So the x value is going to give you one y value. Yes, there's no any other x value that is going to give us negative 2. So it's only this 3 that is going to give us negative 2. So this method here, we call it 1-to-1. Now let's make an example with a parabola. So let me just do a parabola graph like this, for example. There we go, right? Now, if we have a parabola like this one, let's just say this is negative 1. Let's use x as a negative 1. Now, how do we do it? Wherever there is x, you just draw a line that is vertical here. And then wherever it intersects them, as you can see, it's going to intersect them. The value that you're going to get here is going to be a y value. Now, at this point, let's say maybe y is 3, right? There's nowhere else where this negative 1 is going to give you a different value. So in this case now, the negative 1 of x is going to give you positive 3. So this is 1-to-1, right? Any x value on this graph is going to give you one y value. Any x value. If you connect at any point here, there's going to be one y value and one x value. So this is another method that you can use to identify or to distinguish between function and a relation. I hope you guys managed to understand this one, guys. Right, now let's see how do we able to see if it's a relation or not. Now, when it's a relation, let me just show you another trick. This is the simplest trick. When you have a graph that cuts y twice, it's a relation. For example, if you have a graph like this one here, which is a circle, it cuts how many times? It cuts y how many times? It cuts y 2 times. So if it cuts it 2 times or more, just know that it's a relation. It cuts it here and also cuts it there. So it means it's a relation. Any graph that cuts y-axis twice or more, just know it's a relation. This is the simplest of them all. Another graph like that, which is a relation, could be a semicircle like this one. It's gonna cut at this point here and also at that point. As you can see, it cuts once and also cuts the y-axis twice. So this means this is a relation. I hope you guys can able to see this. Now how about the other method? Because there are 2 methods of distinguishing the relation and function as well. Now this one, it's 1 to 2 or 1 to more, but basically it's 1 to 2. So let me show you that method that I was using. Now, for example, on a circle, right, if any x value, let's say this is 2, that gives you 2 or more y values in a graph, just know that it's a relation. So just know that the graph is a relation. For example, let's use this 2. If we to draw a vertical line here going downwards there, this point here, our y is going to be positive y, and at this point here our y is going to be negative y. As you can see, x, which is the x value, gives you 2 y values. So this is 1:2. Actually, 1 x value gives you 2 y values. So just know, if you come across that, just know that this is a relation. Now let's use another example of a graph, right? Let's say we have a graph like this, a hyperbola. Let's say we have a hyperbola. As you can see, now the hyperbola is no longer cutting at y. Which one is this? Is this a relation or is this a function? Right? How do you do it? It's very simple. Look, you just take any x value. Let's say this is positive 2. If it cuts the graph twice, just know that it's going to be a relation. If it cuts once, it's going to be a function. So let's look at this. If you draw a vertical line like this, this cuts only once. So it means these 2 gives you 1 y value on this graph. So it's 1:1, right? But then what if we have a graph like this one, which is more like a central hyperbola? So how are we going to do this? Look, it doesn't matter, guys. If I take any value here, let's say this is 3. If I draw a vertical line and it cuts twice on this, it means that this 3 gives me 2 y values on the graph, because this is going to be a positive y and that is going to be a negative y. So this becomes what? A relation. Remember, this is 1:2. There we go. So that's how you do it, guys. I hope you managed to understand this. If you didn't manage to understand, you can leave a comment and I'll try to answer you to my level best. But then, if you to look at the graph that we just drew now, it cuts how many times? It cuts the y-intercept how many times? It only cuts it once here. So this is a function. Now, if we use the other method, you can take any x value and you draw a vertical line. You will see you're going to only have 1 y value. For example, let's just take this -1. So if you draw a vertical line on a -1 like that, on the graph is going to cut or is going to intercept only once. Now it means that -1 is going to give you whatever y is here. So we can say y maybe is -1,5. So -1 gives you -1,5 of y. So this is 1 into 1. It's 1 into 1. So this negative 1 is going to give you only this y value here. So guys, this makes it a function. So there are two ways of doing this. So rather use the one whereby it intercepts the y value once to say it's a function. If it intersects twice, you say it's a relation. The 1 to 1 and 1 to 2, it needs you to understand better. But I hope you guys managed to understand this one. I will make a video deeper on this, so I'll try to explain it to my level best on that video. But anyway guys, if this helps you to understand, do not forget to like, share, and also comment on the comment section. Guys, we are done with 1.2.2. Now it's time for us to do the last question, which is 1.3. Right, let's look at 1.3. As you can see, 1.3, the one has to draw a neat graph of an inverse of x is equaling to 1 over 5 natural log y. So I'm going to copy this question, paste it where there is space, and try to draw it. All right, let's look at 1.3. Now this question here, it says draw a neat graph of an inverse of x is equaling to 1 over 5 natural log y. Now before you draw this graph, guys, you need to write the inverse equation of this graph here. So the inverse, you just swap x and y. So wherever there is x, you put y is equaling to 1 over 5 natural log, and then wherever there is y, we put x. So you swap your x and y. There we go. So that's what you do. So from now on, we're going to use this inverse equation to draw or plot our graph. But then the method that you're going to use to plot our graph, it's easier to use the table method. So I'm going to sketch the table here and insert the values. And then from there, we're going to start plotting the graph. All right, guys, as you can see, we have our table here. So before I insert the x values, I need to mention something about the natural log graph or the log graphs. What you need to know is the log graphs, they tend to asymptote at y-axis. Here's what I mean. Meaning the log graphs, they look like this, the shape of the log graph. Some will look like that. Others will look like this, going this way. And then others will be on the other side, you know? And others will be looking this way on the other side. What I'm trying to highlight here is that these log graphs, they never ever touch the y-axis. It means that it asymptotes. So for this specific graph that we're doing here, it's going to look like this one here. So it's going to asymptote on the y-axis, and also it only has positive x values, meaning on the table, you can only include positive x values on this table and rather include very small numbers of those x values. Now, also, you cannot have x as 0 because it doesn't touch the y-axis. So if x is 0, you know that x is 0 on a y-axis. So I'll start with 0, 5. And then I continue with 1, 2, and 3. I think these points here, they will be enough. This will give us 4 points. So from here, what you do is we're going to start substituting these x values to this part here of the equation. So let's start. So when x is 0, 5, what is our y? Now, if you put this on your calculator, you'll have negative 0.14 approximately, right? And then we go to the next point. When x is 1, what is our y? So if you put that on the calculator, our y is going to be 0. Right, we continue. When x is 2, what is our y? It's going to be 0.14. This time around, this is positive. The last point here, when x is 3, what is our y? It's going to be 0.22. As you can see now, we have all the points. Now we can start sketching the graph. So let me erase this. Right, now that we managed to draw our Cartesian plane, it's time for us now to plot the graph. But before we plot the graph, I just like to mention something about the scales here. Look at the y-axis. I decided to use 0, 1 to 0, 2, 0, 3. So the scale is 0, 1. Now, the reason why is because when I look at the y values here on this table, I can see it's 0, 1 and 0, 2 and so on and so on. So we can use that scale on the y-axis. And x-axis you can use the normal numbers, which is 1, 2, 3, 4, 5. Now it's time for us. Let's sketch the graph. Now let's look at the first point. The first point says when x is 0, 5, y is negative 0, 1 form. So 0, 5 for x obviously is going to be between 0 and 1. So it's in the middle. It's half of 1. So it's going to be there. So you take your ruler, you draw a line that is going downwards like that. There we go. And then for y coordinate, which is negative 0, 1 form, you go to the y-axis and you look on the negative side of y-axis. Now 1, 1 form, it's somewhere above 0, 1. Okay, somewhere here. So it could be in the middle because 1, 1, 4 is very close. Is very close to the middle of 0, 1 and 0, 2. So we can say somewhere there, right? And then here. So at this point where these two lines that you just drew, where they intersect, that is your point. Now we are done with this point. Now let's go to point number 2. When x is 1 or y is 0. So this point here, it's exactly there because x is 1 there and y is 0 there. All right, so the third point where x is 2, our y is going to be positive 0, 1, 4. So if x is 2, we take a ruler again, we draw a line vertical that is going upwards because we're going to have a positive y. And then our y is going to be 0, 1, 4. So 0, 1 is this point here. 0, 1, 4 is going to be somewhere almost in the middle between 0, 1 and 0, 2. So somewhere there, you draw a line that is horizontal. And then wherever these lines intersect, you put a point there. And then the last point where x is 3 and then y is 0, 2. Again, you do the same thing. You take a ruler, you draw a line that is passing on 3 upwards on the vertical. And then you look for 0, 2 on your y-axis. So 0, 2, it's supposed to be a little bit above 0, 2 because this is 0, 2. Maybe to make it 2, you have to go a bit above. So from here, and then you draw a line that is horizontal, right? And then if the line intersects with that, now that becomes the point. As you can see now, we have all the points. It's time for us to just connect the lines. So let's connect the lines. Okay, as you can see now, this is our graph. Now this graph, like I said, the log graphs, they always asymptote on the y-axis. So this graph will continue and asymptote towards the y-axis. And then on the other side, on the first quadrant, is going to keep on growing exponentially. All right, so as you can see, guys, this is how you actually draw this graph. Now, what is most important here is this intercept of x here, which is 1 and 0. Please indicate it because it's very important. And also the shape of this graph is also very, very important. And the rest is not really that important. But for the purpose of understanding, make sure that you show everything that you need to show in this graph. All right, guys, I hope this helped you to understand how to draw an inverse graph of a natural log. This is actually how it looks like. Just in case you didn't understand, you can leave a comment in the comment section where you ask a question and I'll try to answer you to my level best. If this part of the video helps you to understand how to draw an inverse graph of a natural log, do not forget to like the videos. If also you haven't subscribed to the channel, subscribe to the channel. All right, guys, so let's look at question 2. And let's try to solve the problem. All right, so as you can see, here's our question 2. So question 2 consists of 2.1, which are complex numbers, 2.2 also complex numbers, 2.3 which are as well complex numbers, and 2.4 which is determinant. So we're gonna start with 2.1, which is all this here, the question that you see here, and I'm gonna copy this question, paste it where there's space, and let's start solving. All right guys, as you can see, here is our question 2.1. Now 2.1, they want us to solve the value of x and y simultaneously using complex numbers if given the following equations here. So we have this following. So we need to solve for x and y. Now before we start though, I just like to clarify some things here. Usually for imaginary number we use I, but sometimes we use j instead of I. So just in case you didn't know that j also stands for imaginary number, just know that j stands for imaginary number. Now, before we solve for x and y simultaneously, there are certain things that we need to consider. One of the things is the bracket. So we need to get rid of the bracket. So on the first step, we're gonna have to use FOIL to get rid of this bracket. So let's do it. So on the left hand side, we're gonna multiply these two brackets. We're gonna start with 3 multiplied by -6. This is gonna give us -18. There we go. And then we say 3 multiplied by j, that is gonna give us plus 3j. Right, now we come to 2j. 2j multiplied by -6, this is gonna give us -12j. There we go. And then 2j multiplied by j, this is going to give us plus 2j squared is equaling to. Now we go to the right hand side. Also, we get rid of this bracket. Now we're going to multiply this x with -2. We're going to have -2x. There we go. And then we say x multiplied by 4j. This is going to give us plus 4xj. There we go. And then we come to yj. Yj multiplied by -2. This is going to give us -2yj. There we go. And then we have positive yj multiplied by 4j. This is going to give us plus 4yj squared. There we go. So here, guys, it's time for us to simplify it further. Now, another thing that you need to pay attention to when you solve for x and y is the powers of the imaginary number. As you can see on the left hand side, the fourth term, which has 2j squared, we need to simplify it. And also on the right hand side, the last term here, which has 4yj squared, we also need to simplify it. And another thing, again, to add on that, we have to add or subtract the like terms. So first of all, let me highlight the like terms. On the left hand side, we have this 3j and -12j. These are like terms. They need to be added or subtracted. On the right hand side, we don't have any like terms. You only have this 4yj squared that needs to be simplified. So when we continue, we're gonna write this -18, and then we know that plus 3j minus 12, this is gonna give us minus 9j. There we go. Now plus 2j squared, I'm just gonna add this here. J squared is equal to -1. Just in case you don't know this information, you can go to the description. I left a video that explained this. So you can go to that description, click on that video and learn more. And the very same video will pop up on the top right of this video. Go and click on that video, watch the full video that explained all this. This is the same as I squared, by the way, right? It's the same as I squared. J squared, I squared, they are all equaling to -1. So what we can do here is wherever there is j squared, we substitute with -1. So we're going to substitute with -1. There we go. Minus 2x plus 4x j minus 2yj plus 4y. So wherever there is j squared, we're also going to substitute with -1. All right, so we are done with this step. Now it's time for us again to work with like terms on both sides. So on our left hand side, when you look here, we have a real number, which is 18, and also -9j, which is imaginary number. But we also have these two multiplied by -1, which is going to make it a real number. Now we have -2 minus 18. This is going to give us -12. 20 on the real number. But the imaginary number, here we have ij. There we go. Now we look on our right hand side. On our right hand side, we're gonna rewrite this as they are. They don't have like terms, majority of them. So we're gonna rewrite it 4xj and then minus 2yj. But what about this last term here? The last term here, we have 4 multiplied by y multiplied by -1. This becomes negative 4y. There we go. Now that we have this, we check whether we have like terms. On the left hand side, we know that there is no like terms. On the right hand side, still we do not have the like terms. So when it's like this now, it's time for us to do the grouping. But before we start doing the grouping, remember that your equations on the left hand side and the right hand side should be simplified like this. You should have only imaginary number with only I or j to the power of 1. If you have any other power, you need to simplify it. You also need to have the equations in a linear. You should not have fractions in your equations. If there's a fraction, you need to deal with them. And also you need to deal with brackets. So if that is not available, it's time for us to do the grouping. Now, the grouping part of this, you have to group by real numbers. So basically what you're doing here is you only gonna write the real numbers that you see here on this step there. So on the left hand side, you have to only write real numbers. So a real number here is negative 20. If there's no any other real number on this, you have to equate them. On the right hand side, again, you have to write real numbers. So real numbers here, we have negative 2x. And if you continue 4xj, that is not a real number because it has j. Negative 2yj, that is not a real number because it has j. But we have negative 4y. So we can say minus negative 4y. This here is the grouping of real numbers in this equation there. Then from here, we simplify it. We can divide by -2 throughout because -2 is a factor here. All right, so let's do it. -20 divided by -2, that is going to give us 10. -2x divided by 2, this is going to give us x. And then -4y divided by -2, that's going to give you plus 2y. Now we can make x subject of the formula on this one. So we can say x is equal to, if we transpose this positive 2y to the other side, we're going to have 10 minus 2y. So we can say this is equation number 1. There we go. Now it's time for us to do the other grouping. So let me first erase this part here. All right, on this side here, we're going to do the grouping of imaginary numbers. So you can write on top here, imagine, to indicate that these are imaginary numbers. All right. Okay. So what you should do here, you're going back to this equation here. You only take imaginary numbers. So imaginary numbers in this equation here, they are the ones with j in this case. So wherever you see a number with j, you write it. So let's start with our left-hand side. On our left-hand side, we have -9. So you just write this -9 as it is, right? If you don't have anything that has j on the left-hand side, then we just equate them. On the right-hand side, we're only going to write the values or the numbers that has j in them. So we have 4x, and then we also have minus 2y, because both of these, they have j with them, right? So some of you might get confused. Why did you not include the j in this equation here? What you should know is that for the fact that you wrote imagine here, it means that all these numbers underneath here, they are imaginary numbers. So you don't really have to write this j here. All right, so this becomes equation number 2. Now you have two equations. You have equation number 1 there, and you have equation number 2. Now, if you can look at this, you can say substitute equation 1 into 2. Right, so we're going to use the substitution method. Now, equation 1, we know that x is equal to 10 minus 2y. So when we substitute it to equation 2, wherever there is x, we're going to put this 10 minus 2y. So let's do it. So on the left hand side, we all have negative 9 is equaling to 4. So wherever there is x, we're going to substitute with 10 minus 2y. And then minus this 2y as well, because this is 2y. Then from here, we continue this side. This is going to be 9 on the left-hand side. On the right-hand side, we multiply by this form. This becomes 40 minus 8y minus 2y. So from here, we deal with the like terms. We know that we can take this 40 to the other side, which is going to be negative 40 minus 9. We transpose it to the other side. And then here the like terms, and this is going to give us minus 10y. There we go. And then here we continue. We're going to have minus 49 is equal to negative 10y. Then what you can do here, we can just divide by negative 10 throughout. So divide by negative 10, divide by negative 10, even this side. And then we'll be left with, let me create more space. 49 over 10 is equaling to y. So y basically is 49 over 10. I would say rather leave it like this, guys. Now from here, we know what y is. Now to get x, we must substitute. So I'm going to do it here. Substitute y into equation 1. There we go. So you substitute the answer that you got here into the equation number 1. Now, wherever there is y, you substitute with 49 over 10. So let's do it. So I'm just going to rewrite it here. X is equaling to 10 minus 2. What is y? Y is basically 49 over 10. There we go. Then from here, you start solving. So x is equaling to, so you can say 10 minus 49 over 5. Then the final answer, which I'm going to write here, guys, is going to be 1 over 5. So x is equaling to 1 over 5, while y is equaling to 49 over 10. Guys, just in case it's your first time watching this type of a problem, I've done a video where I explain how to solve for x and y. I'm going to leave that video on the description. Go and watch that video. It will explain some of the things that I did here a little bit further. Go to the description, and also you can click on the top right of this video. There will be an icon that will pop up there. Click on that icon and watch that video. Again, if it so happen, guys, that you didn't understand some of the things that I mentioned here or I did here, you can leave a comment, ask a question. I'll try to answer you to my level best. Yeah, and again, guys, if this helped you to understand how to solve for x and y in a complex number, you can like the video, and also you can subscribe to the channel if you haven't subscribed. Just don't forget to share this to your friends. All right, guys, we are done with 2.1. How about we do 2.2? All right, let's look at 2.2. Now here is our 2.2 here, guys. So I'm gonna copy this question here and post it where there's a space, because they want us to simplify this here. Right, here's our 2.2. Now they just want us to simplify the following here. It doesn't look so clear, so I'm going to write this on top here. Basically, this question looks like this. You have polar, and then we have 1 over 2 pi. All this is divided by polar. All right, we have 3 pi over 12, right? Multiplied by polar, we have 2 pi over 12. So these here, guys, are complex numbers in polar form. Just in case you don't know much about polar form, this is just in polar form. But again, what we have here, we also have the radians. These are not in degrees. All right, so we need to change these radians into degrees. So in order for you to change these radians, you must multiply it by 180 divided by pi. So each and every radians that you see here, we need to multiply them by 180 divided by pi. So let's do that. Let's start with the numerator there. So if we say half pi multiplied by 180 divided by pi. All this is divided by the same polar, but this time we have 3 pi divided by 12 multiplied by 180 divided by pi. Multiply, because this is also different. We have 2 pi divided by 12 multiplied by 180 divided by pi. There we go. Now, if you continue here, we're going to have polar on the numerator, this one here, which is going to be 90 degrees divided by. Now, on the denominator, we're going to have polar 45 degrees multiplied by polar 30 degrees. There we go. So basically, this is what you're going to have in degrees. So let me continue on the other side. All right, so we're going to continue here. Now, what you need to know about polar form, guys, is that when the complex numbers are in a polar form and they are multiplying and dividing, the angles or the modulus, they tend to add and subtract. Now, for example, on the numerator, there's nothing you can do at the moment, so because it's the only 90 degrees. But on the denominator, these two angles here, which is 45 and 30, they're going to add each other. Remember, they're in a polar form. So it's going to be 45 plus 30 degrees, right? They're still under the polar. So if you continue here, the numerator, you're just going to write 90 degrees divided by 75 degrees, right? Polar. Right, so if you continue there, when it's like this now, the numerator is going to be subtracted by the denominator when it comes to the angle. So when you continue like this now, 90 degrees is going to be subtracted by 75 degrees. This here is another rule that you're supposed to know about polar form. So when they subtract this, they're going to give you 15 degrees polar. Now, this is your final answer, but some of you can write it as 615 degrees. Guys, this is the final answer. I hope you managed to understand this one. But just in case you didn't understand, there is a video that I made that explained the multiplication and the division of the complex number in a polar form. You can go to the description, go and click on that link, and also the very same video, it will appear on the top right of this video here. I hope you guys managed to understand though. If it so happened that you didn't understand and you can't watch the video, you can also leave a comment in the comment section. I'll try to answer you to my level best. And if this helps you to understand how to solve this type of questions, do not forget to leave a like. And also, if you haven't subscribed, subscribe to the channel. And also share this to your friends. All right, guys, we are done with 2.2. We are going to do 2.3. Let's look at 2.3. Now, 2.3, they want us to convert the following problem here, complex number. So I'm going to copy this question here and post it where there is a space and try to solve it. So let's go to that question. All right, let's look at 2.3. Now, this question here, they want us to convert this complex number to polar form. As you can see, this complex number here is actually in a rectangular form. Now, before we do some conversion, you need to understand certain things here, which I'm going to explain at the moment. Now, look, guys, first of all, you need to understand that the real number, which is 7 here, is representing x. And then y, it's represented by the imaginary number, which is negative 12. Again, just in case you don't remember, j and I, they are also imaginary numbers. So j also represents imaginary. Just in case you come across j, just know it's the same as I. Right, so when you draw the agar diagram, you need to know exactly where this is happening. For example, we know that x is positive and y is negative. When you look at your cast diagram here, let me just do it very quickly because that's where we draw our diagram, x and y. Now, where is x positive? X is positive on this side, but where is y negative? Y is negative on this side. So it means that this is happening on the fourth quadrant, or this z here, it's on the fourth quadrant. And how do we represent the fourth quadrant? Usually it's 360 minus theta. So we'll get to this later on. What you should also know about this is that real numbers are on the x-axis and the imaginary numbers, they're on the y-axis. So this is what you need to know about this so far. Now, in order for us to convert from rectangular to polar form, we need to calculate two variables or two unknowns. One of the unknown is modulus, right? And the other one is argument. So we're going to start with modulus. So modulus, it's more like calculating the radius. So if you use the Pythagoras theorem and you calculate for modulus, is the same as when you're calculating for radius. So modulus is the same as radius. Now, if you use the Pythagoras theorem, we know that r squared is equaling to x squared plus y squared. Now, if you make r subject to the formula, you need to square root both sides. So if you square root both sides here, we're going to have x squared plus y squared. There we go. Now we start substituting from the original question here, from this complex number here. We know that x is equaling to 7 and y is equaling to negative 12. So we square root here, and that's it. Going to the original, we know that x is 7 squared. So remember, x is 7 plus minus 12 squared. Right. So if you continue here, we know that r is going to be, if you put that in the calculator, it's going to be the square root of 193. So this is your modulus at the same time. This is equaling to m. So m is equaling to square root of 193. Or you can leave it with the decimals, but rather leave it like this as a sum. Now that we are done with modulus, how about we calculate argument? Right. So argument is basically the angle. So when we calculate for argument, we're going to use tan theta, which is equaling to y over x. But there is something that I need you guys to understand. We have two types of argument. Sometimes you can have a negative argument. Sometimes you can have a positive argument. Let's go back to our cast diagram here. So when you go back to a cast diagram, we know that if we start from 0 going this way, which is a clockwise, your angles will be negative. So when you get a negative argument, it means that you are rotating in a clockwise direction. So if that is the case now, it means that we have to substitute 12 with negative. So let's do it. So we can say theta is equaling to, if we take tan to the other side, this is going to become arctan. There we go. Now we know that negative 12 over 7, because y is negative 12 and then x is equaling to 7. Now if you put this in your calculator, you'll get negative 59.74 degrees. This here, guys, is the argument when you are rotating from 0 in a clockwise direction. Now this is a negative argument. Let me just write this here, negative argument. But when you are looking for positive argument, usually that's what they are asking for, by the way. So you do the following. We know that the fourth quadrant is represented by 360 minus theta. Now this angle that you got here becomes your reference. So you can say 360 minus 59.74. And then your argument is going to be 300.26 degrees. Guys, this is when they say find a positive argument. So this is how you do it. So your final answer is as follows. You're going to have the square root of 193 as argument, polar 300.26 degrees. This here, guys, it is when you have a positive argument. Usually this is the one that they require, is the one that they want from your exams. And also some of you can write it like this, is still fine. This is another notation of polar form where you can multiply by cos 300.26 plus, imagine, sine 300, let me just open space here, comma 26 degrees. this is another way of answering this question here, guys, right? This is another way. So you can leave it like this or like that. But if they are fine or they never specify which argument you should use, you can also leave this answer in this form, where we have negative 59.74 degrees. This is also fine, guys, but only when it is not specified whether to leave your answer with a positive argument or not. And then you can also continue and write it like this: the square root of 193 multiplied by cos negative 59.74 plus imaginary sine negative 59.74 degrees. All right, guys, so this is how you do it. As you can see, I've tried to cram everything inside this page, but basically this is how you convert from rectangular to polar form, one of these four notation. I hope you guys managed to understand this. Just in case you don't understand how to do this, you can go to the description. I've left a video where I explain how to convert from rectangular to polar form. If you want clear explanation, go to that video, click on the description, and the very same video is going to appear on the top right of this one here. All right, guys, if it so happened that you can't watch the video and you don't understand, you can also leave a comment in the comment section and I'll try to answer you to my level best. But then if it so happened that you manage to understand this type of a question, please do not forget to like, share the video, and if you haven't subscribed to this channel, subscribe to the channel. Guys, we are done with 2.3. It's time for us to do 2.4. Right, let's look at 3.4. As you can see, 3.4, the one has to determine the value of z only using determinants if we are given this matrix here. So I'm going to copy this question here, and then we do this problem on the side. All right, guys, as you can see, here's our 2.4, where they want us to determine the value of z only using determinants if we are given the following equation then. So we have three equations which contains y, z, and x. Now, the next thing about this here is that the x are all the first terms, and then the second terms contains y, and then the last term they contain z. So there's no rearranging that is needed here. But before you solve this, you need to know about the cofactors. So in order for you to solve this, first of all, you need to rewrite the matrix here. You only take the coefficients of the x, y, and z. For the first term on the first equation, the coefficient is positive 2. The second term on the very first equation is going to be negative 1 because we have negative y. And then the last term is going to be positive 1. So you just write them like this. And then you go to the second equation where the first term is just positive 1. The second term is going to be negative 2. Remember, you take the coefficients here. And then the last term is going to be positive 2, this 2 here. And then the last equation, the first term is going to be 3. The second term is 1, and then the third term is also 1. Then you have your matrix here, or you have the notation where we can use determinants. Now, when you do determinants, again, there is something that you need to consider. We have what you call cofactor. So let me just write cofactor here, cofactor. Now, a cofactor, it actually means that the first term is going to be positive, the second term is negative, first term is positive. The first term on the second row is going to be negative, positive, negative. And then the last row is going to be positive, negative, positive. Remember, guys, you have columns and you have rows. So columns are the ones that are vertical and rows are the ones that are horizontal. So we're going to use this cofactor to calculate our determinant. Now, this is a third order, guys. In the third order, you need to select at least one row or one column to use those numbers in that row or column as your minus. So I'm going to use my first row. I think the first row will do. So if I take this first row here and use everything that is in here as my minus. So every number that is here, it's a minus. So let's start. So if I use the first row, it means that if the minor is 2, which is this positive 2, so we're going to cancel a column that is part of this minor. So we're also gonna do the very same thing here. So we're gonna cancel everything that is part of this is being cancelled. So we're gonna only consider these here. So let's consider. Now let's change the color. So we're gonna say 2. Remember this minor here, which is 2 and also is positive. So we're gonna do it. Write negative 2, 2, 1, 1, because this is what we are left with. All right, now that we are done with the minor when it's 2, how about when we do the minor when it's negative 1? Remember these ones here, we use them as minor. So if minor is negative 1, means we need to cancel the numbers. But then let us not forget, we have minus, so it's going to be minus on the second term of this row. And we also have the minor, which is minus 1. So we have minus 1, right? And then what are we left with here? We're left with 1 and 2, 3, and 1. There we go. Now the last one here, if the minor is 1, so this one here, remember we have to move it. So let's move, let's cancel the numbers. So if the minor is 1, let's look at the cofactor. Cofactor is positive, so this is going to be plus. And then we only have this one here. So what are we left with here? We're left with 1 minus 2, 3, and 1. There we go. So these are the terms. Now, in order for you to calculate the determinant, guys, you have to do the cross multiplication. Meaning, let me just highlight very quickly. I'm going to show you how we do it. This term here, the first one on the matrix multiplied by the last one. And then the product of that is going to be subtracted by the product of 2 multiplied by this one here. Let me just show you what I mean by that. Right. So when you continue here, we just continue very quickly. So when you continue here, we know that D is going to be equaling to 2. And then we do the multiplication. Negative 2 multiplied by 1. This 2 multiplied by 1. Right. Minus. All this, you minus them. And then it's going to be this 2 multiplied by 1. So the first multiplied by the last. So it's going to be 2 multiplied by 1. Now, this one, since it's negative multiplied by negative minus negative 1, it's going to be plus. Right. Now, we can say 1 multiplied by 1. Remember, first multiplied by last. So it's 1 multiplied by 1 minus 2 multiplied by 3. So don't forget to put them inside the bracket. 2 multiplied by 3. So it's the second multiplied by the third. Then you put them inside the bracket. So here we have plus 1, right? Even if you don't write it, just like here, it's fine. You can say 1 multiplied by 1. So it's 1 multiplied by 1 minus negative 2 multiplied by 3. So we can say negative 2 multiplied by 3. There we go. So if you continue here, we're going to have D, and then we're going to have 2 multiplied by negative 4. Right. And then we have minus 5. And then we have plus 7. And then this is going to give us, if we put all this in the calculator, negative 6. So we know that our determinant is going to be negative 6. Now, in order for us to find the z, we need to find the determinant of z. So in order for you to find the determinant of z, you just have to take this 4, 6, and 8 and place them on the third column, because this is where z is. If you can look at this on the third column, this is our z. So I'm going to rewrite it on the side so that you can able to solve it. So you keep the others as they are. For example, these 2 here, you keep it 2, 1, and 3. And then you also keep this one in the middle is 1, and you keep the 2, and you also keep the 1. What the ones that changes is the coefficient of z. Now, instead of putting the coefficient of z, we're going to put the answers. For the first row, the answer was 4. For the second row, the answer is 6. And then for the third row, the answer is 8. So this here becomes our matrix. Now, let me create space so that we can find the z determinant. I'm going to do it here. So ZD, we're going to do the very same thing. I would say to you guys, don't change your minus. So take the first row numbers as your minus. Now, ZD, we know that if we say the minor is 2, like that, we want to use this 2. So here's what we're going to do. So we're going to say 2, but any column that has this minor, we do what? We cancel. There we go. And then we start. So what is it that we're going to be left with? We're going to be left with negative 2, 6, 1, and 8. There we go. And then we go to minor negative 1. If minor is negative 1, what is it that we left with here? Now it's time for us to move this. Move it. Negative 1. There we go. We're going to be left with 1, 6, 3, and 8. But let us not forget our minor is negative. So how we do it? Remember, we're going to be minusing because we have minus on the cofactor. Our minor is also negative 1. So we're going to be left with 1, 6, 3, and 8. There we go. I hope you guys can able to see that. Now, the last one, let me just create more space because this one requires more space. And the last one, where the minor is 4, this 4 here. Now, we can say, since our cofactor says this is going to be plus, so we can say plus here, plus, right? But then we have our minor, which is going to be 4. So let's continue. So if 4 is our minor, we have to take this line and cancel the row where 4 is. All right, so we're going to be left with 1, minus 2, 3, and 1. There we go. So this is what we have. Now from here, we start calculating the dz, okay, the determinant for z. Now we know that we multiply the first and the last minus by the product of the second and the third. So let's do it. So it's going to be 2. There we go. And then it's going to be negative 2 multiplied by 8. Negative 2 multiplied by 8 minus 6 multiplied by 1. There we go. This is what you're going to have. Then we come to this one. Negative and negative, this becomes positive. And then we say 1 multiplied by 8 minus 3 multiplied by 6. There we go. Right. And then we say plus. Here we have the minor, which is 4. And then we can say 1 multiplied by 1. 1 multiplied by 1 minus negative 2 multiplied by 3. There we go. So guys, this is how you do the calculations. Now let's do the calculations. dz is equal to, now let's do the first one here. We know that our minor is 2 here. So inside here, if you put this inside the bracket, you'll have negative 22. So we go to the next one. So you can multiply everything inside here. It will give us negative 10. And the last one, which we have plus 4, which is our minor, inside there we have 7. There we go. So you start multiplying, simplifying everything. If you put everything inside your calculator, you will have negative 26. So your determinant for z is going to be negative 26. All right, in order for you to find z, the equation is going to be dz divided by d. Now we know that dz is negative 26, and our d, the one that we calculated earlier on, or determinant, is negative 6. So the answer here is going to be 26 over 6. You can also write it in this form as well. It's still fine. So by the way, this is how you calculate your unknown. I hope you guys managed to understand this. This was a bit challenging, really, because I haven't done anything on determinants specifically other than the question papers. So this is a bit long and also can be confusing. I hope though you managed to understand. If you didn't, you can leave a comment in the comment section and I'll try to help you to my level best. But if this helps you to understand better how to find the unknown in determinants, you can leave a comment and also you can like the video and share the videos to your friends. But if you haven't subscribed to the channel, subscribe to the channel because I've made lots and lots and lots of videos. We are done with question 2. I hope this question was easier for you. So let's look at question 3 and let's see how we're going to solve these problems. Right, as you can see, here's our question 3 here. Question 3 consists of 4 questions and all these questions are trigonometry. So we're going to start with 3.1 and try to solve this question here. So what I'm going to do here, I'm going to copy this 3.1 paste it where there is space, and solve it. All right, guys, here's our question 3.1. Now, this question here, they want us to solve for the value of x if we are given the following expression here. So we have 1 over cos sec, open bracket, x minus 20 degrees, close bracket. All this is equaling to 1 over sec, open bracket, 20 degrees plus x, close bracket. And then they also give us the domain here. So the domain states that the x should be greater than 0, but less than 90. So whatever x that we're going to find here, or whatever the value of x that we're going to find here, it should be an acute angle, meaning it should be within the first quadrant. Now, let's start solving this problem here. Now, let's look at our left-hand side. Now, we have 1 over cos sec, open bracket, x minus 20 degrees, close bracket. Now, if you can look at this trigonometric function, this is actually the inverse of sine. So we can rewrite the left-hand side as sine x minus 20 degrees, right? Because this is the inverse. And we look at the right-hand side. Now, on the right-hand side, we also have 1 over sec, open bracket, 20 degrees plus x, close bracket. Now, this as well, it's also an inverse. This is an inverse of cos 20 degrees plus x. Now, when it's like this, guys, we use the inverses. Just in case you don't know much about inverses or you want to learn more about inverses, there is a video that I'm going to leave on the description. And also the very same video is going to pop up on the top right of this video. That video explains more about inverses. Right, so let's look at this here. Now we have the left-hand side, which is sine, and the right-hand side, which is cos. This method, guys, it's solving for x by using co-ratios, right? So if you can look on the left-hand side, we have sine, which is a co-ratio of cos. Now you have to decide which of these two you have to change so that it can look like the other. Now, I would prefer to change the right-hand side. So I will write sine x minus 20 degrees. All this is equaling to. So when you change cos, or when you find the co-ratio of cos, open bracket, 20 degrees plus x, it's going to be sine, right? Now it's going to be 90 minus, open bracket, 20 degrees plus x. Right, let me explain this very quickly. As you can see, the cos, open bracket, 20 degrees plus x is actually positive. For the fact that this cos is positive, it means that this is happening on the first quadrant, because everything on the first quadrant is positive. Now the co-ratio of this one here, it's sine minus 90 degrees and the whole angle that you see here. Now, when it's like this is the co-ratio of cos on top there. So from here, now that you have sine on the left-hand side and you have sine on the right-hand side, they start to fall out. So as they fall out, you'll be left with x minus 20 degrees. And then on the other side, which is the right-hand side, you're going to be left with 90 minus, open bracket, 20 degrees plus x. Then from here, on the left-hand side, you just rewrite it. There's nothing you can do at the moment. And on the right-hand side, you're going to have to multiply by negative to remove the bracket. So we're going to have 20 degrees minus x. Now you start to do the like terms. Now on the left-hand side, you can also leave it like that. It's still fine. But on the right-hand side, we have 90 degrees minus 20. This is going to give us 70 degrees minus x. If we transpose this 20 on the left-hand side to the right-hand side, it's going to be positive. And also if we transpose this negative x to the left-hand side, it's going to be positive. So we're going to have x, transpose this x to the other side, plus x because it was negative. And then this is going to be equal to, we have 70. And then we transpose this 20 to the right-hand side, and then we're going to have plus 20 degrees. Now we're going to have 2x, and then this is going to be 90. Now, divide by 2, throw out our x is going to be 45 degrees. Right. So this is how you actually do this question. This is how you solve for x. As you can see, our x is within our domain. It's greater than 0 degrees and also less than 90 degrees. All right, guys. I hope you managed to understand this question here. Just in case you didn't understand, I will leave another video where I actually explain further or clarify how to actually solve for x with co-ratios. And also, I'm going to try to leave the co-ratio videos as well on the description. Go to the description and also check out the icon on the top right of this video to watch those videos. Okay, guys, now that we are done with 3.1, I hope you managed to understand. If this helped you to understand better, do not forget to like, share the video. If you haven't subscribed to the channel, subscribe to the channel. All right, guys, now that we're done with 3.1, how about we check 3.2? Right, guys, now let's look at 3.2. Now, here's our 3.2 here. Yeah, I will copy this question here and try to paste it where it's spaced so that you can be able to solve it. All right, guys, let's look at our 3.2. Now, 3.2, they want us to simplify as far as possible. Now, we are given the following expression. We have cos x divided by 1 minus sine x minus cos x divided by 1 plus sine x. So what we're going to do here, guys, we have to simplify this. So let's solve this problem here. Now, first of all, we need to find our LCD. So we're going to take the denominators of both the terms. Right, let me just stretch it a bit here. So the denominator of the first term is going to be 1 minus sine x multiplied by the denominator of the second term, which is going to be 1 plus sine x. Then the next step here is to divide each denominator with our LCD, and then we multiply the answer with our numerator. We're going to divide this 1 minus sine x, and we're going to be left with 1 plus sine x multiplied by cos x. Right, minus. Then we go to the second term. We divide the LCD with our denominator of the second term, which is going to be 1 plus sine x. So we're going to have 1 plus sine x giving 1 multiplied by 1 minus sine x multiplied by cos x. So this is going to give us cos x multiplied by 1 minus sine x. There we go. Right. All right. The next step is to simplify further. Now let's look at our numerator, the first term on the numerator. We have to remove the bracket by multiplying by the cos x outside the bracket. So we will say 1 multiplied by cos x, we're going to have cos x. And then we say plus sine x multiplied by cos x, we're going to have sine x cos x. Then we're done with the first term on the numerator. Minus. Then we multiply by negative cos without 1. This is going to give us cos, negative cos x. Negative cos multiplied by negative sine x is going to give us positive sine x cos x. There we go. Let's not forget they are multiplying. Divide by. Right. Now, on the denominator, we need to remove the bracket. So we do the following. 1 multiplied by 1. This is going to give us 1. 1 multiplied by positive sine x is going to give us positive sine x. And then we say negative sine x multiplied by 1 is going to give us negative sine x. And then we say negative sine x multiplied by positive sine x. This is going to give us negative sine x squared. There we go. Then from here, we do the like terms. So let me highlight the like terms. On the numerator, we have cos and negative cos. So they're going to cancel each other. And then what we left with, we have sine x cos x and another sine x cos x. So these, they're going to give us 2 sine x cos x. There we go. And then we divide them. On the denominator, we also have the like terms. Now we have sine x and negative sine x. They're going to cancel each other. So on the denominator, we're going to be left with 1 minus sine squared x. All right, when I look at this step here, I can see that, I'm going to write it here. I can see that we have 2 sine x, then cos x. Right, divide by 1 minus sine x squared. This here, guys, is the same as cos squared x. Remember, this here is derived from cos squared x plus sine squared x is equaling to 1. When you make cos subject of the formula here, cos squared x, you'll be left with 1 minus sine squared x, which is the same as this. So instead of writing this, we can substitute with cos squared x. Now that we have the following, we can start dividing. We know that we have 2 sine x. We know that since this cos squared, it is multiplying itself twice. One of the cos is going to divide with the cos on the numerator. And then you're going to only left with only cos x. And the answer here is going to be 2 and x, because sine over cos gives you tan. Right, I hope you guys managed to understand this one. It was a bit complex, but not really that much. All you need to know is to simplify this further and try to use your trigonometric knowledge and identities that you know of. But guys, this was not that difficult. If it so happened that you didn't understand this, you can leave a comment in the comment section. I'll try to explain to you to my level best. But if it happens that this video helped you to understand how to simplify this type of questions, you can leave a like and also share the video. If it so happen that you haven't subscribed to the channel, subscribe to the channel. Guys, we are done with 3.2. How about we do 3.3? All right, guys, let's look at 3.3. As you can see, 3.3, this is the question for 3.3. I'm going to copy this, paste it where there is space, and try to solve it. All right, guys, here's our 3.3. As you can see, they want us to prove that sine 2x minus sine x divided by cos 2x plus cos is equaling to sine x over cos x plus 1. Now, when you do the proving, it's best to choose the most complicated side. As you can see, between the left-hand side and the right-hand side, the most complicated side is the left-hand side. So let's pick the left-hand side, prove it, and let's see if it's going to be the same as the right-hand side. Now, in order for you to solve this, you need to know things like double angle identities, and all types of trigonometric identities. So let's first look at our numerator then. Now, when I look at our numerator, I can see that this sine 2x is a double angle identity. I can rewrite it like this: 2 sine x multiplied by cos x, right, minus sine x. There we go. And then we divide underneath them, right? And then when I look at our denominator, the first term on our denominator, we have cos 2x. Also, this is a double angle identity. Now, you can write it this way: 2 cos squared x minus 1 plus cos x. These here, guys, are actually double angle identities. Just in case you don't know much about double angle identities, you can go to the description where I've made a video about double angle identities. In fact, I derive them so that you can know how to derive them as well. You can go to that description, watch that video, and also the very same video will pop up on the top right of this video here. All right, so let's continue. Now, when we continue, you can see that on the numerator, we have a common factor. So we take out our common factor, which is sine x. And then inside the bracket, we're going to be left with 2 cos x minus 1. And then on the denominator, we need to rearrange this. We can say 2 cos squared x plus cos x minus 1. All right, when you look at our denominator, this is actually quadratic. We have 2 cos squared x plus cos x minus 1. We can actually factorize this. Now, let's continue. On our numerator, we're still going to rewrite it as it is. Open bracket, 2 cos x minus 1. And then let's factorize our denominator. Now, we can say we have 2 brackets like that. Just do this. And then we can say 2 cos x and cos x. Remember, when you factorize, guys, you must be able to go back. If you say 2 cos x multiplied by cos, it's going to take you to 2 cos squared x. Right. Now, let's look at our last term here of this quadratic. We have -1. What are the factors of -1? It's actually 1 and -1. So you need to be careful, where exactly do you actually place our +1? So first of all, you're going to put 1 there, because if you say 1 multiplied by 1, you're going to have this one. But then where exactly are you going to place the negative and the positive? Now you look at the term in the middle, we have cos x, which is positive. So the one that is going to multiply with 2 cos x must be positive. And then the one that is multiplying with cos x must be negative. So basically, this is how you do the factorization. All right, when you look at this step here, we have 2 cos x minus 1 and another 2 cos x minus 1 on the numerator. So these two, they will divide each other. So when you continue here, we're going to be left with sine x divided by cos x plus 1. Now, if we can look at this here, it's the same as that. So we can say, therefore, the right-hand side is equaling to the left-hand side. This was not difficult, guys. It just needed you to know the double angle identities and also know how to simplify the trigonometric functions that we have here. All right, guys, if this video helped you to understand better, do not forget to like, share, comment, and also not forgetting to subscribe to the channel if you haven't subscribed to the channel. If it so happen again that you didn't understand, you can leave a comment on the comment section. All right, guys, we are done with 3.3. How about we go and do 3.4? All right, guys, now let's look at 3.4. Now, 3.4, they want us to simplify this question here. Before we continue, I just want to clarify something here. Some people got confused. How exactly are we going to simplify this? So this question here is basically similar to 3.3, where you can prove that this left-hand side is the same as the right-hand side. So let me just copy this question, paste it, and let's solve it. All right, they want us to simplify this question. So this question, it's a bit confusing because people don't know where to begin. It's either we are proving or we are just simplifying. I would say this question here, they wanted you to prove that the left-hand side is the same as the right-hand side. Because if you punch this, this should give you 2 minus root 3. Meaning now you must able to prove that this side here is equaling to that side. Now, I will show you how to do this, guys, very quickly. Now, I'm going to take the right-hand side and let's solve this. But before I start, I need you to understand that in order for you to solve the right-hand side, you need to understand special angles. So we have these special angles here on this triangle. Just be quick about it. All right, so we have these special angles here. As you can see, we have sine 30 and we also have cos 30. So these ones here, they will need us to use the special angle. Even though they never specified whether to use a calculator or not, but I would say when you come across this type of equation, rather use special angles. Just in case you don't know much about special angles, I've made a video on special angles. Go to the description. There will be a link based on those special angles, and also the very same video will pop up on the top right of this video. Right, so let's start. First of all, you need to change sine 30. So we know that sine is the same as opposite over hypotenuse. Now, when you look at this triangle here, what is our opposite of 30? It's going to be 1, right? The hypotenuse is going to be 2. Right, so this is divided. So I'd rather use this type of divide by 1 plus cos 30. So I can put this in the bracket, 1 plus, but what is cos 30? Remember, cos is adjacent over hypotenuse. So our adjacent here for 30 is root 3, and our hypotenuse is 2. Right, so when it's like this, it's easy for us to continue and solve this problem here. Right, so let's continue. But before we continue, just in case you don't know much about the trigonometric ratios, I will leave the video on the description. Go and watch those videos on trigonometric ratios so that they can help you to understand better. But let's continue here. Now, on this side here, we're going to leave that half as it is. And then we're also going to divide. But then inside the bracket, we're going to start solving. So we're going to put our LCD here, which is 2. This is going to give us 2. And then we say plus. And then we say 2 divided by 2 is going to give us 1. Multiplied by root 3, this is going to give us root 3. Right. Then when you continue here, this half is going to remain like this for now. And then we do the multiplication. Remember, guys, when you change division into multiplication, this bracket here, these numbers here, the numerator become a denominator and the denominator become a numerator. Meaning that 2 becomes a numerator. And then 2 plus root 3 become a denominator. So when it's like this, it means that we have 2 divided by 2, which is going to give us 1. Let me continue here. So we will be left with 1 over 2 plus root 3. This is the answer, but I wouldn't say leave it here. You should start rationalizing. So let's rationalize. So when you rationalize, you multiply by 2 minus root 3 divided by 2 minus root 3. As you can see, this gives you 1. But at the same time, you are rationalizing. So on the numerator, you say 1 multiplied by 2, 1 multiplied by negative root 3. So you're going to have that on the numerator. But on the denominator, we say 2 multiplied by 2. This is going to give us 4. 2 multiplied by negative root 3. This is going to give us negative 2 root 3. And we say root 3 multiplied by 2. This is going to give us 2 root 3. And then we multiply root 3 multiplied by negative root 3. This is going to give us negative 3. Right, so let's continue. When you continue here, on top there, on the numerator, we're going to have 2 minus root 3. But on the denominator, we have the like terms. So let me highlight the like term very quickly. So we have negative 2 root 3 and positive 2 root 3. So these ones, they will cancel each other. But at the same time, we have 4 minus 3. So 4 minus 3, we're going to be left with 1. So let me just do it here. 1. If I continue here, we know that we left with 2 minus root 3 divided by 1. Even if you don't write that one, but this is the same as tan 15. If you can punch tan 15 degrees, you will get 2 minus root 3. Guys, I know this was a bit ambiguous, but I hope you can manage to get the answer here, or you manage to understand how exactly they wanted the answer. If it so happened that this video helped you to understand this type of a question better, you can leave a like, comment, and also share the video. If you haven't subscribed to the channel, subscribe to the channel. If you didn't understand, do not forget to leave a comment and ask the question, and I'll try to answer you to my level best. Guys, we are done with 3.4. Now that we are done with 3.4, we're also done with question 3. All right, guys, let's look at question 4 and let's see if we can be able to solve the problems. All right, so here's our question 4. So question 4 consists of 5 questions. Now we have 4.1, 4.2, 4.3, 4.4, and 4.5. So we're going to start with question 4.1, which is this one here. We're going to copy this question, paste it where there is space, and solve it. So let's copy the question. All right, guys, let's look at 4.1. Now, 4.1, they want us to determine the following limit. Now, the limit of this expression here, when x approaches infinity. Now, we have 3 methods that you can try in order for you to solve or find the limit of this expression. Now, the first method, which is very simple, we call it direct substitution. Basically, the direct substitution is you do a direct substitution. Wherever there is x, you substitute with infinity. So we can say 2 multiplied by infinity to the power of 3 minus infinity to the power of 2 plus 3 multiplied by infinity plus 9. divide by 5 infinity to the power of 3 plus 3 multiplied by infinity minus 4. Now, this method here, we're going to get infinity over infinity, because anything multiplied by infinity, anything plus infinity, anything subtracted by infinity is infinity. So we don't have a limit when you use the first method, which is a direct substitution. Now, let's do the second method. The second method, if the first method gives you infinity or 0, you go to the second method. Now, the second method, you try to simplify this equation. Now, when I look at this expression here, you cannot simplify, because to factor the numerator, it is not that simple. It will have a remainder. And also to factor the denominator also. So you cannot simplify this expression. If the second method is not working, now let's try the third method. Now the third method is you divide each term with x that has the highest power. Now when you look at this expression here, the x with the highest power here is x to the power of 3. Each term here, you have to divide it with x to the power of 3. Now let's try the third method. Now, here's how you're going to do it. You're going to start with the first term on the numerator, which is going to be 2x to the power of 3. Divide by x to the power of 3, because x to the power of 3 is the x with the highest power, minus. Now, the second term of the numerator, we have x to the power of 2 divided by x to the power of 3. The third term is 3x divided by x to the power of 3 plus the last term on the numerator divided by x to the power of 3. You have to do the very same thing, divide by 5 x to the power of 3 divided by x to the power of 3 plus on the denominator, the second term, we have 3x divided by x to the power of 3. And then the last term, we have 4 divided by x to the power of 3. As you can see, each and every term of this expression here is divided by x to the power of 3, because x to the power of 3 is the x with the highest power on this expression here. So this is the third method I'm talking about. Now, if you continue here, let's look at the first term on the numerator. We have 2x to the power of 3 divided by x to the power of 3. This x to the power of 3, they will give you 1 multiplied by 2. So we're left with 2 here. And then the second term on the numerator, we have x to the power of 2 divided by x to the power of 3. So here we're going to left with 1 over x. And then we look at the third term on the numerator, this x, and then here we're going to be left with x to the power of 2. So we're going to have 3 divided by x to the power of 2. The last term of the numerator, there's nothing we can do there. We're just going to write it as it is, 9 over x to the power of 3. Divide by, we continue the first term, we have 5x to the power of 3 divided by x to the power of 3. X to the power of 3 divided by x to the power of 3, 1 multiplied by 5. So we left with 5. And the second term on the numerator, we have 3x divided by x to the power of 3. This is going to give us 3 divided by x to the power of 2. Minus the last term on the denominator, we don't do nothing. It's 4 divided by x to the power of 3. Right, now that we managed to solve it this way, the second step is to do direct substitution. Now, wherever there is x, we substitute with infinity. The first term on the numerator, which is going to be 2, we leave it like that, there's no x there, minus 1 divided by, now the second term on the numerator, we have 1 over x, so wherever there is x, we substitute with infinity. There we go, plus. And then the third term on the numerator, we have 3 over x squared, but wherever there is x, we substitute with infinity. Let's not forget this one is squared. Plus the last term, we have 9 over x to the power of 3, but this time we're going to put infinity to the power of 3. There we go. All this, we divide them. As we divide, we have 5 on the denominator on the first term. The second term, we have 3 divided by x squared, but we're going to say 3 divided by infinity squared. Remember that. Minus, we have 4 divided by x cubed, but we're going to have 4 divided by infinity cubed. Right. So there is another information that you need to know about infinity. Any number divided by infinity is 0. Any number. As long as you have infinity dividing them, it's going to give you 0. So let's continue. Let me create a space here. Now, as we continue here, the first term on the numerator, we have 2. The second term, we have minus. We have 1 divided by infinity. Remember, any number divided by infinity is going to give you 0. The second term also plus 0. The third term plus 0, because all of them, they're divided by infinity. Divide by. The first term on the denominator, we have 5. And then the second term is 3 divided by infinity squared. That is going to give us 0. The third term is going to be 4 divided by infinity, which is going to give us 0. So the final answer here, we have 2 over 5. So this is our limit. Guys, this question here, it was not really that difficult. All you needed to know is we have these 3 methods to actually find our limit. Just in case you didn't know, I've made a video explaining these methods on how to find the limit. Just for clarity, go to the description, click on the link of that video to watch the video, and also that video will pop up on the top right of this one here. Alright guys, this was not that difficult. All you needed to know is this method. Just in case it so happened that I didn't understand, leave a comment in the comment section and I'll try to explain to you to my level best. But if this video helped you to understand how to solve this type of a problem, please do not forget to leave a like and also you can share. And if you haven't subscribed to this channel, subscribe to the channel. Alright guys, we are done with 4.1. How about we do 4.2? Alright guys, now that we're done with 4.1, how about we do 4.2? Now as you can see, 4.2, we are given the following question here. So I'm going to copy this question, paste it where there is space, and we solve it. Alright guys, let's look at 4.2. Now 4.2, they want us to differentiate the following with respect to y. Now we are given this polynomial here. What you need to understand here guys, this time around they say with respect to y. Most of the time we are used to differentiate with respect to x. They just swap things around. Before you do any deriving or differentiation, you need to look each and every term and start to notice which rule is it, and again, is this term need to be simplified or not. So when I look at this expression here, I can see that term number 2, it needs some simplification. Term number 3, it also needs some simplification. So you cannot differentiate yet without simplifying. So let's first simplify this expression here. When you simplify, you still say x is equaling to, because you're not yet differentiating. Now, you rewrite the ones that are fine, like the first term, we have y to the power of 3, it's fine, and then we say plus. We cannot differentiate the second term like this, because it has the exponent on the denominator. So the base must be on the numerator. So if we take this e to the numerator, it's going to be e, and then the sign of the exponent is going to be positive. It changes, so it's going to be 2y, right? Then we go to the third term. Again, the third term, we cannot differentiate with the trigonometric functions underneath there on the denominator. We need to simplify this. So in order for us to simplify this one, it's very simple. We just have to use the inverse. So what is the inverse of 1 over sec? If you still remember, 1 over sec is the same as cos. But then we have 2y. There we go. And then the fourth term is fine. We're just going to rewrite it like this. And then the fifth term is going to be fine like that. Just in case you didn't understand the third term where I say 1 over sec is cos, there is a video of inverses. I will leave the video on the description. Go and watch that video. And also the very same video will pop up on the top right of this video here, so that you can understand the inverses. Now that our expression is linear like this, we can start differentiating. Now, do not forget, this is going to be dx over dy. There we go. We are differentiating with respect to y, so it should be like this. Now, let's look at the first term. When we look at the first term, this here is a standard derivative. So when you differentiate the standard derivative, we're going to say 3 multiplied by y, 3 minus 1. That's what we do, right? Because this is a standard derivative. Then we go to the second term. The second term is exponential because y is an exponent then. When we differentiate the second term, we're going to say 2e to the power of 2y natural log e. Just like that. This is how you do the differentiation of exponential equation. Now let's go to the third term. Now the third term is a trigonometric function. Now we have cos 2y. So the differentiation of cos 2y is going to be 2. First of all, you multiply by these 2 here. And then what is the differentiation of cos? It's going to be minus sine 2. There we go. Right, now we go to the fourth term. Now the fourth term, we have 2 natural log y. Now this is a natural log differentiation. Now when you differentiate the natural log, it's going to be negative 2, and then you divide by y. The last one is going to give us 0 because there is no y here on this one here, guys. Remember, we are differentiating with respect to y. So this is going to give us 0. So you can continue and simplify this further. You can write 3y to the power of 3 minus 1, which is going to give us 2. Plus, you can say 2e to the power of 2y natural log e. But natural log e is equaling to 1. Even if you don't write it, you leave it like that. And then we go to the third term. Now the third term is 2 multiplied by negative sine 2y. So it's going to be negative 2 multiplied by sine 2y. And the last term is going to give us minus 2y minus 0. Even if you don't include this 0 here, it's fine because we already included the 0 there. Guys, this is how you do this one here. This polynomial, it was not that difficult to differentiate. It needed you to know each and every term, the type of equations that we have. We have the standard derivative here. We have the exponential derivative on the second term. We have the trigonometric derivatives on the third term. And we also have the log derivative on the fourth term. And the last term, it was a constant. So it needed you to know all the type of equations that were given here and the type of derivatives that you must apply. Just in case you don't know how to solve this problem, I'll leave a video where I solve a problem similar to this. In fact, I will leave the playlist where I have multiple of questions similar to this, where I solve them. You can click on that link so that you can watch those videos on the playlist, and the very same link will pop up on the top right there with the playlist. Alright guys, I hope you managed to understand this. This was not that difficult. If this video helped you to understand, do not forget to like, share, comment, and also if you haven't subscribed to the channel, subscribe to the channel. So if it so happened that you didn't understand, do not forget to leave a comment as well, and I'll try to explain to you to my level best. Alright guys, we are done with 4.2. How about we do 4.3? Alright guys, we are done with 4.2. Now let's look at 4.3, guys. I'm gonna copy this question here, which is a 4.3, paste it with a space and try to solve it. Alright guys, here's our 4.3. Now 4.3, they want us to differentiate. Now we have y is equaling to natural log kx, and then they want us to use a function of a function, which is a chain rule. Now, this question here, guys, it needs us to use this method here, which is known as a chain rule or a fraction of a function. Now, when you use this method, you must understand that you have the outer function and the inner function. Now, the outer function, I'm going to highlight it with the red. So, the outer function is the whole thing from natural log kx. That is your outer function. Now, the inner function is kx. So you must equate the inner function with u and the outer function with y. So, for example, if we say u is equaling to kx, which is the inner function, therefore, y is equaling to natural log u. If u is equaling to kx, y is equaling to natural log u. So we substitute here. So we use this method here. Now, we need to differentiate both these equations. Let me start with u. When you differentiate u, it's going to be du over dx. We are differentiating u with respect to x. What is the differentiation of kx? The answer is going to be k. There we go. Now let's look at dy over du. Now, this is a natural log. So when you differentiate natural log, it's 1 over u. Right, just in case you don't know how to do the natural log differentiation, you can go to the description. I made a video there, and also the very same video will pop up on the top right. It explains how the differentiation of natural log works. Now from here, to get your dy over dx, you must multiply du over dx with dy over du. Right, let's continue. I'm going to continue. Dy over dx is going to be, what is du over dx? Du over dx, if you can look here, is equaling to k. Multiply. What is dy over du? If you look here, dy over du, it's 1 over u. So multiply by 1 over u. Right. So if you continue, dy over dx is equaling to k over u. But if you go back here, what is u? U is k multiplied by x. So we have to substitute u with kx. So we can say k divided by, wherever there is u, we substitute with kx. We have kx. Then if you look at this, we have k divided by k. So the final answer, dy over dx, is going to be 1 over x. Guys, this is our final answer. I hope you guys managed to understand this one. It was not really that difficult. All you needed to know is the chain rule, or a function of a function. Now, there are many ways of solving this, but this is the way that I could explain it better. So just in case you want to understand more about this chain rule, I've made a video explaining how exactly to identify, how to use this method. You can go to the description, click on that link where I explain the chain rule, and also the very same video will pop up on the top right of this one. Alright guys, if this video helped you to understand how to differentiate using the chain rule, do not forget to like and share the video. And also, if you haven't subscribed to the channel, subscribe to the channel. If it so happened that you didn't understand still, you can leave a comment in the comment section. I'll try to help you to my level best. Right, we are done with 4.3. How about we do 4.4? Right, we are done with 4.3. How about we do 4.4? Now, we're going to copy this question here of 4.4, paste it where there is space, and let's do it. All right, guys, here's our 4.4. Now, 4.4, they want us to differentiate the following here. They say y is equal to e to the power of x divided by sec x using the quotient rule. Now, this is one of the rules that you're supposed to use to differentiate this. Now, before you differentiate this, you need to understand that you have your denominator and your numerator. Now, you can say y is equal to f of x, that will be your numerator, divided by g of x, that will be your denominator. When you differentiate this using the quotient rule, dy over dx, there is a formula for it. You first differentiate f of x prime multiplied by g of x, then minus f of x multiplied by g of x prime, right? And then you divide by g of x, then you square that g of x. Basically, this is how you use the quotient rule. Now, it means that we need to differentiate f of x and g of x. So we can say here f of x from this equation is equal to e to the power of x. And we also say that g of x from this equation is sec x. There we go. Now, from here, what can we do is we need to differentiate both of these. F of x prime is the same. It's going to be e to the power of x. As for exponents, this is the same. Just in case you don't know, you can go to the description. I've made a video explaining the differential of exponents. You can go to the description and also to the top right of this video. That video will pop up here. And then g of x is the trigonometric function. Now, how do you differentiate sec? So g of x prime is going to be sec multiplied by tan x, right? So now all you need to do is to substitute all these there. There we go. Now let's create a space. dy over dx is going to give us, what is f of x prime? Our f of x prime is going to be e to the power of x, so e to the power of x. What is g of x? Our g of x is sec x, so we say sec x, right, minus. Now, the second term on the numerator, we have f of x. What is f of x? Our f of x is e to the power of x, so it's e to the power of x multiplied by g of x prime. What is g of x prime? It's going to be sec x multiplied by tan x, this one here. So multiplied by sec x multiplied by tan x, divide by g of x squared. Remember, g of x is equaling to sec, so you're just gonna write sec x, but do not forget that you need to square it. So this is your final answer. Guys, I wouldn't advise you to go further than this because they just wanted you to use the quotient rule. They didn't mention to simplify further. So this is how we actually differentiate this equation with quotient rule. I hope this helps you to understand how to do this one. Just in case you don't know what's happening here, I've made a video explaining the quotient rule. I'll leave that video in the description, and also the very same video will pop up on the top right of this one. Alright guys, if this video helped you to understand, do not forget to like, share, comment, and also if you haven't subscribed to the channel, subscribe to the channel. Right, we are done with 4.4. How about we do the last question, which is 4.5. Alright guys, now that we're done with 4.4, how about we do 4.5? Now this is the last question of question 4. So we're going to copy this question here, which is 4.5, paste it where there is space, and let's try to solve it. Alright guys, here is 4.5. They want us to determine the coordinates of the point of inflation of y is equal to x to the power of 3 minus 2x squared minus 8x with an aid of differentiation. Now, the point of inflation, guys, is a point at which the cubic graph, let's say for example like this one, where it increases or decreases. Let's say it is a point of inflation. In order for you to determine the point of inflation, you need to derive this equation twice. So that second derivative is actually equaling to 0. So d squared y divided by dx squared is equaling to 0. So the second derivative, just know that it is equaling to 0. So when you do the first derivative, let's do it here, dy over dx, we must use the standard derivative. So the first term is going to be 3x squared minus 4x. There we go. And the last term is going to be minus 8. So this is the first derivative. Now the second derivative, d squared y divided by dx squared. The first term is going to be 6x minus 4. The last term is going to give us 0 because it's a constant. Let us not forget that the second derivative is equaling to 0. So when the second term is equaling to 0, we can say 6x is equaling to 4. If we take this 4 to the other side, it's going to be positive. And then we divide by 6 throughout. This is going to give us x is equaling to 2 over 3. Now this is the x coordinate of the point of inflation. Now if you are looking for the y coordinate of point of inflation, you need to go back to the original equation from the statement there. Wherever there is x, we must substitute with 2 over 3. Right, so I'm just going to do it here. Y is equaling to, the first term is x to the power of 3, where we can say 2 over 3 to the power of 3. Remember, x is supposed to be substituted by 2 over 3. The second term is negative 2 multiplied by x squared. So negative 2, wherever there is x, we substitute with 2 over 3. But we have squared there. Then we go to the last term where we have negative 8 multiplied by x. But wherever there is x, we substitute with 2 over 3. Right. So you punch this on a calculator, the answer that you're going to get is going to be. Now, this is your y coordinate of the point of inflation. So you can say point of inflation is 2 over 3, that is your x, and your y is negative 5,93. Or you can write this 0,66 for your x, and your y is negative 5,93. So your x is this and your y is that. Guys, you really didn't need to do much when you solve this one here. It was really straightforward. All you needed to know is that second derivative is equaling to 0 when you are looking for the coordinate of point of inflation. And then you can solve for x after doing the second derivative because it's equaling to 0. And then you can use this x coordinate and substitute it to the original equation to find the y coordinate. And then you will have your x and y coordinate for point of inflation. And then when it comes to deriving here, this is a standard derivative, just in case you didn't understand this part here. You can go to the description. I left a video where I explain the standard derivative. And also the very same video will pop up on the top right of this video here. All right, guys, we are done with question 4. But to look at question 5, and let's see if we can able to solve it. So here's our question 5. As you can see, question 5 consists of 5.1, 5.2, 5.3, 5.4, which has 5.4.1, 5.4.2. So we're going to start with 5.1, and then we're going to copy this question here, paste it where there is space, and let's try to solve this problem. All right, let's look at 5.1. Now, 5.1, they want us to evaluate this polynomial that you see here. Now, this polynomial, they want us to actually integrate it. As you can see, we have a sigma there, and we also have dx. This means that we are integrating with respect to x there. The sigma means that we are integrating. Whenever you see these two, it means that we are integrating with respect to x. Now, before we solve this problem, you need to understand that integration is the opposite of differentiation. So in order for you to understand or to master this part of mathematics, you need to master differentiation. Before we start, let's look at this polynomial. We must look at each term very, very careful. Now, the first term that we have here, as you can see, we cannot integrate like this. We need to simplify it because this here is an identity. The second term as well, we cannot integrate it because we have the trigonometric ratio on the denominator. So we need to do something about this. We need to simplify it. As for the third term and the fourth term, they are all fine. So before we integrate, let's simplify the first and the second term. Now, since we are simplifying, the sigma will also remain here to symbolize that we haven't integrated yet. So open bracket. Now, let's start with the first term. As you can see, the first term here, we have 2 sine x multiplied by cos x. Now, this here is a double angle identity for sine. So you can write it like this, sine 2x. Right. Just in case you don't know much about double angle identities, I'll leave a video on the description where I actually derive these double angle identities. The very same video will pop up on the top right of this video that you're watching here. Now, let's go to term number 2. Now, we say plus. We have 3 over sine squared x. Now, we cannot integrate with this type of term here. We need to simplify it. Now, this 3, we can keep it on the numerator, but then we need to use the inverse in order for us to get rid of this sign on the denominator. What is 1 over sine? So 1 over sine is actually cosec, but since this one is squared, so we must put squared there, x. So when we simplify this, this is going to become 3 cosec squared x plus 3e to the power of 3x plus pi to the power of 3, close bracket, dx. Right. Now that we managed to simplify this, do not forget to also include dx, because this means that we haven't yet integrated. Everything is simplified. It's time for us to integrate. So when you integrate, you can equate this to y. Now let's start with the first term. This here is a trigonometric ratio that needs to be integrated. Now you need to know the integral of sine 2x. Now the integral of sine, we know that is going to be negative cos, and then we have to write this 2x there. But then when you integrate the trigonometric ratio, you always divide by the coefficient of x. In this case, this 2 here. So you must divide it by 2 then, right? Now let's go to the next term. Now we can say plus, right? But then we have 3 here. You also need to know what is the integral of cosec squared x. Now, like I said, if you know your differentiation, you will know what is cosec squared x. The integral of cosec squared x is actually negative cot x, right? Since our coefficient here is 1, even if we don't divide by 1, it's fine, guys. Then we go to the third term. Now, the third term, when you look at it, it's the exponential integral. Now, we have the coefficient of everything here, which is 3, and then we're still going to write e to the power of 3x, right? But then when we integrate this, we're also going to divide by the coefficient of x, this 3 here, which is going to be them. And then multiply by natural log, the base, our base here, which is going to be e plus. Now, the last term can be tricky, guys. We have pi to the power of 3. If you do this in a rush, you might find yourself mistaking this with x. This is pi. It means it's a constant. Now, when we integrate constant, we just multiply that constant with x. So we can just say x multiplied by pi to the power of 3. Now that we managed to integrate everything, let us not forget to add c here. This c represents that we are doing indefinite integrals and also represent the constant. Right, now that we are done, it's time for us to simplify this question further. Now, the first term, there's nothing we can do here. We just write it as negative cos 2x divided by 2. And then the second term, you just multiply by 3, whatever that is inside here. So we're going to have negative 3 cot x. And then the third term, as you can see now, we have 3 divided by 3. We're going to be having 1. And then on the numerator, we're left with e to the power of 3x. But then on the denominator, we still have natural log e. Just in case you didn't know, natural log a is equaling to 1. So this thing here, this e to the power of 3x is divided by 1. You don't have to write it, guys. It's fine. Now let's go to the fourth term. The fourth term, it's fine like this. Just rewrite it as it is. X multiplied by pi to the power of 3 plus c. So guys, this here is our final answer. Just in case, guys, it so happened that you didn't understand, you can go to the comment section, comment. I will try to help you to my level best. But just in case you didn't know as well, I've already made videos on polynomials like this one and also on each and every integral that you see here. I already made videos introducing the concept here. So I will leave the playlist of those polynomials where I solved them. And also that playlist will pop up on the top right of this video. But if this type of the video helped you to integrate this polynomial, do not forget to like, share, and also comment if you have any other comment. If you haven't subscribed to the channel, subscribe to the channel. All right, guys, we are done with 5.1. I hope this makes sense to you. So let's go and do 5.2. All right, guys, here's our 5.2 here. Now we're just going to copy this question, paste it where there is space, and let's solve it. Right, let's look at 5.2. Now 5.2, they want us to evaluate the following definite integrals. Remember, the first question was indefinite integrals. Now this is a definite integral because we have the limit, the upper limit and the lower limit. So they want us to find the definite integral of 2 tan x. We're also integrating with respect to x. Just in case you don't know, this dx means that we are integrating with respect to x. We also have the sigma there, but we do have the upper limit and the lower limit. Now, before we do anything else, I would advise you guys to change this pi over 4 because it's in rads into degrees. Just in case you don't know, this is how you do it, guys. You say 180 divided by pi multiplied by pi over 4. This here is going to give you 45 degrees. Rather, do the calculations in degrees. So we can rewrite this and say sigma 45 degrees, the upper limit, and the lower limit is going to be 0. And then we say 2 tan x dx. Remember, we are integrating with respect to x. Now, when you integrate here, guys, you're going to integrate what is inside the bracket here. So we can say y is equal to, now you must have a bracket then. You say 2, and then from there, what is the integral of tan? Just in case you don't know the integral of tan, the integral of tan is natural log sec, then x, and then you close. Guys, the definite integral, we do not add c. It's not necessary. You can add it, but it's not necessary because at the end, they're going to cancel each other. And then here on top here, you're going to write the upper limit, right? And then here, you're going to write the lower limit, which is 0. Guys, this is the upper limit, and that is the lower limit. These are not powers. Just in case you get confused, these are not powers. This is to show you that you have the upper limit and the lower limit. We continue. Now, the first bracket is going to be for the upper limit. So you're going to write 2 natural log sec x. Then here you write the upper limit, which is 45. And then you subtract with the second bracket of the lower limit. But the integral inside the bracket is the same. It's going to be 2 natural log sec x. And then the lower limit is going to be 0. Guys, I repeat, these are limits, not powers. Just in case you get confused, these are just limits. Now, the next step here, you have to substitute wherever there is x with the limit. So let's continue. Y is going to be the first bracket. You're still going to write 2 natural log sec. Now, instead of writing x, you're going to put the upper limit, which is 45 degrees. There we go. Minus. You're going to write the same integral here, which is going to be 2 natural log sec. What is the lower limit? Which is going to be 0 degrees. There we go. I hope this makes sense. Let me create a little bit of space here. Now, when it's like this, you cannot use your calculator because you have sec here. So the best way of doing this, guys, is to use the inverses. Now, let's continue. Y is going to be the first bracket, 2 natural log. Now, what is the inverse of sec? It's going to be 1 over cos, but 45. When it's like this, you can able to use your calculator. You do the very same thing on the lower limit bracket. Now, we can say 2 natural log, and then 1 over cos 0. There we go. That is your lower limit. Now you can use a calculator. When you use a calculator, the first bracket is going to give you 0,693. And then the lower limit is going to give you 0. So our limit for this question is going to be 0,693 unit square. Usually we answer this with unit square. Guys, to add on this, whenever you're calculating the definite integral, avoid adding plus c. You don't add c because these are definite integral. Even if you do add c, they're gonna subtract each other because you have this negative here. And at the same time, the lower limit, it's always subtracting the upper limit. So the integral of the lower limit will subtract the integral of the upper limit. All right, so here we decided to use the inverses because you don't have sec on your calculator. Unless you do have sec on your calculator, it's fine. But if you don't have sec on your calculator, rather use the inverses, which is 1 over cos 45. And then you just substitute, you put this on your calculator, you get 0,693. And you put that on your calculator, you get 0. So the final answer is 0,693. Guys, this is how you do definite integral. Just in case you didn't understand how I did this, you can leave a comment in the comment section. I'll try to explain to you to my level best. And again, at the same time, there is a video that explains the definite integral in depth. So you can go to the description, click on that video, and also the very same video will pop up on the top right of this video here. All right, guys, we are done with 5.2. We're going to do 5.3. So if you haven't subscribed to the channel, subscribe to the channel. And also, if this question helped you to understand the definite integral, do not forget to like and also share this to your friends. If you have a comment, you can also comment. All right, guys, let's go and do 5.3. All right, guys, now that we're done with 5.2, let's look at 5.3. Now, 5.3, here's our 5.3 here. We'll copy this question, paste it where there is space, and let's solve it. All right, guys, let's look at 5.3. Now, 5.3, they want us to simplify this here. Now, as you can see, we're still integrating because we still have a sigma here, and also we have dx there. So we are integrating with respect to x. But before we integrate here, we need to simplify first. When you look at the numerator, we have 3 multiplied by x to the power of 3 minus 81. And we look at the denominator, we have 2x minus 6. So before we integrate this, we need to simplify it first. So let's simplify this here. Now remember, when we simplify, we keep the sigma as usual and dx. So let's start with our numerator. Now, when you look at the numerator there, we have the common factor. Guys, before you simplify, always look for a common factor if there is one. So we have a common factor here, which is going to be 3. So we take out this 3, and then inside the bracket for the first term, we're going to be left with x to the power of 3. Now, when you look at the second term, when you take out the common factor, which is 3, we're going to be left with negative 27. There we go. And then we divide. We also have the common factor there, which is 2. We take out 2 as a common factor. On the first term, we're going to be left with x. And the second term, we're going to be left with negative 3. Right, let's not forget that we still have dx. Remember, we haven't yet integrated. All right, so when we look at this as well, we need to simplify it further. When I look at the numerator here inside the bracket, we have x to the power of 3 minus 27. This here, guys, is actually the sum and the difference of 2 cubes. Just in case you don't know much about it, this is actually the formula for the sum and the difference of 2 cubes. If we have x cubed minus y cubed, the answer is going to be x minus y multiplied by x squared plus xy plus y squared. There we go. Whenever there is a negative between the term, this is how you do this one. When there is a positive for the very same between the two terms, this is how you do it. It's going to be x plus y, and then we want to have x squared minus xy plus y squared. This here, guys, is what you call the sum and the difference of 2 cubes. So the one that we have here, guys, is this one here, because we have x cubed minus 27. All right, so let's simplify it further. So let's write sigma, and then we can take out these common factors on the numerator and the denominator. For the numerator, the common factor is 3, common factor is 2. Now, what we can do here, we have to first know how to simplify this. So let's look at the numerator. I'm going to open the bracket at the numerator. There we go. Now, look, we can see x to the power of 3 minus 3 to the power of 3. If you say 3 to the power of 3, you're going to get 27. This is going to help you to expand it further. Now, divide by x minus 3. There we go. Let's not forget dx. Remember, we haven't yet integrated. Now, we continue with our sigma. We are still simplifying. We have 3 over 2. There we go. Now, we can apply this method here. All right, so on the numerator, let me just create this line here. We can say the first bracket is x minus 3. Remember, this 3 here. And then the second bracket, we must have x squared. There we go. And then we say plus. Look at this. It's x multiplied by y. So it's going to be positive x multiplied by 1 here on the middle term of the second bracket. So in this case, it's going to be 3 multiplied by x. So it's going to be 3x. Right. Plus. And then when you look at the last term of this, you square the y. So in this case, our y is negative 3. So we can do this. Negative 3 squared. There we go. Divide by, okay, then bracket, then divide by x minus 3. All right, let's not forget dx here. So let's continue because we're still simplifying. Let me just draw a line here, right? Sigma, and then we can say 3 over 2. Remember, these are common factors, and then bracket. Then we draw this line here. The first bracket on the numerator, we have x minus 3. And then the second bracket, we have x squared. We have plus 3x. And then we have plus 9. There we go. Divide by x minus 3 on the denominator, dx. Right. So when you look at x minus 3 on the denominator, we'll divide with x minus 3 on the numerator. So what we left with here, we left with sigma 3 over 2. And then bracket, we have x squared plus 3x plus 9. Then dx. Now, when it's like this, the whole thing now, it is simplified. We can start integrating. Do not forget, guys, these are standard integral. Right, so you can say y is equaling to, now these are common factors. You can write them as they are outside them. So inside the bracket, you integrate each and every term. Now, when we do the standard integral, we know that it's going to be x2 plus 1 divided by 2 plus 1, right? And then we go to the next term. Now, the next term is going to be 3, and then we know that we're going to have x1 plus 1 divided by 1 plus 1. And then the last term, let's look at this term here, which is 9. Guys, 9 is a constant. When it's like this, we just multiply by a variable that we are integrating with respect to. So we can say 9 multiplied by x, then we close bracket. Right, let us not forget plus c. Right, let me create more space. Right, if we continue here, our common factors, which is 3 over 2, we still write them there. Inside the bracket, we're going to write x to the power of 2 plus 1, which is 3, divided by 2 plus 1, which is also 3. Plus, we have 3 as a coefficient, and then we can say x to the power of 1 plus 1, which is 2, divided by 1 plus 1, which is also 2, plus 9x. Close bracket, plus c. Do not forget, guys, this c is outside the bracket. And also c represents the indefinite integral. Let us not forget that one, guys. So from here, we multiply by 3 over 2, which are common factors. So we multiply everything inside with 3 over 2. On the numerator, we can say 3 multiplied by x to the power of 3. This is going to give us 3, x to the power of 3. And then on the denominator, we have 2 multiplied by 3. This is going to give us 6. There we go. Now we continue. Second term. Now we have 3 multiplied by 3x squared. That is going to give us 9x squared. On the denominator, we have 2 multiplied by 2. This is going to give us 4. The last term, we have plus 3 multiplied by 9x, which is going to give us 27x divided by 2. Now that we remove the bracket, we can say plus c. Now, when it's like this, guys, it's not yet simplified. So I'm going to continue this side. So we can say y is equal to, let's look at the first term. We have 3x cubed divided by 6. We can say 3 into 6, it's 2. So we can say x cubed divided by 2. Now, the following terms, even if we don't do anything, we write them as they are fine. We have 9x squared divided by 4. There is no common factor there. It's fine. And then the second last term, we have 27x divided by 2 plus c. So, guys, this is our final answer. I hope you guys managed to understand this one. It was a bit tricky if you didn't know the sum and the difference of 2 cubes, because you couldn't able to simplify this equation that we have here. But I think this question was not that difficult. But just in case, if you find it to be difficult, you can leave a comment on the comment section and you can ask a question wherever you got lost. And also, you can go to the description where I've solved a similar problem like this one. So you can go and watch that problem. I will leave the link on the description, and also I will leave the same link on the icon that will pop up on the top right of this video. Guys, I hope you managed to understand this one. It wasn't easy, but also it wasn't that difficult. Alright guys, if this part of the video helps you to understand how to integrate this type of a problem, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. Alright guys, so this is 5.3. We are done with 5.3. How about we do 5.4? Right, let's look at 5.4. Now 5.4 consists of two questions. So we're going to start with 5.4.1. Then we're going to do 5.4.2 later on. So let me just copy this 5.4.1 and then paste it with a space and let's solve it. Right, here's our 5.4.1. Now, they want us here to sketch the graph of y is equaling to 4x squared and another graph which is x is equaling to 2y squared. And they want us to clearly indicate the area as well as the strip. So when it's like this, guys, we have two graphs here. We have this one here and that one there. Now, when I look at this graph here, this is actually a parabola because you have x squared, right? And this one here, it's more like an inverse of a parabola. Now, in order for you to draw this graph here, guys, you don't really have to stress that much. For the fact that this first graph here, the parabola graph, it has a positive coefficient. It means that it's going to face up. But then for the fact that it doesn't have B and C, the x coefficient and the constant, it means that it's going to pass at 0 point. Right, but there's another way of drawing this graph here. You can use the table, which I'm not going to use it because it's very, very simple to draw this graph. Right, now as for this one, it's also the same way, guys. It's just that it's going to be facing this direction. All right, so let me first draw the Cartesian plane so that you can be able to draw this graph. All right, guys, now that we're done drawing the Cartesian plane, let's draw the y is equaling to 4x squared graph, which is a parabola. Remember, the parabola, when it's like that, it's going to start at 0. So we can say this graph here is y is equaling to 4x squared. Remember, guys, it is passing at 0 point because it doesn't have B and also it doesn't have C. So when it's like this, it's going to only cut at 0 point and it's going to face upwards because our 4 is positive. Now let's look at the other graph, which is x is equaling to 2y squared. Now this graph here of x is equaling to 2y squared is going to be facing this direction here. Also, the very same graph here is going to be cutting at 0 point. Remember, guys, you can also use the table method to draw these graphs. I won't be using the table method because it's very simple to draw these two graphs. So it's going to cut at 0. So obviously this point here. So this here we can say this graph is x is equaling to 2y squared. Now we managed to draw these two graphs here. Now it's time for us to clearly indicate the area. Now, in order for you to indicate the area is between these two graphs. So this is the area that they're talking about here. So this is the area when they say clearly indicate. And then they say you must also indicate the representative strip as well. Now, this strip here, guys, it should be between this point, the point of intersection. So we have the first point here and we have the second point. And also it should be within the highlighted area. So you can put a strip just anywhere as long as it's within this here. As for now, this is how you do it, guys. Don't put it anywhere other than the shaded area and between these points here. And then you just write change in X. So this is your representative strip. Guys, basically, this is how you draw or solve this type of a problem. Now, we're going to continue on this question, on question 5.4.2. But this is how you actually solve this one, guys. You draw these two graphs, and then this area you indicate, because this is an enclosed area caused by these two graphs, and then you show the representative strip within the enclosed area. All right, guys, if it so happened that you didn't understand how to draw or what happened here, you can leave a comment. I'll try to answer you to my level best. And also, if this helped you to understand how to solve this type of a problem, do not forget to like, share, comment, and also subscribe to the channel. Now that we are done with 5.4.1, how about we do 5.4.2, which is a continuation of this. So we're going to use the very same graph to do the next question. All right, we are done with 5.4.1. How about we do 5.4.2, which is this question underneath here. And it's the last question, guys. So I'm going to copy this question here and paste it where there is space. And then let's solve it. Right, let's look at 5.4.2. They want us to calculate the magnitude of the area enclosed between these graphs here. Let's call this one graph number 2, and this one, let's call it graph number 1. So these are the graphs that we drew earlier with the aid of integration. So they want us to calculate the enclosed area between these two graphs with an aid of integration. Now, before we start calculating here, there are certain things that you need to understand here, guys. First of all, we have these two intercepts. Let me just highlight them for the last time, where this graph, they intersect to each other. Now, the first intercept, we know that is at the origin. So the x value is 0 and the y value is 0. So we are fine. But the second intercept, it's where we need to find the x value. What is our x value here? Because we're going to use the x values of this intercept as our limit. The one on the origin, we can say, is the lower limit. And then the one for point 2, we can say, is the upper limit. Right? Because in order for us to calculate this area, we need to use the definite integrals. And when you do definite integrals, we have to have upper and the lower limit. Now, we need to find the x value then. How are we going to find this x value for the upper limit? Very, very simple. What you can do here, we can use the substitution method to find those values. So we can say substitute 1 into 2, or vice versa. Really up to you. You can substitute 2 into 1 or 1 into 2. Let's substitute 1 into 2. All right. So we can say x is equaling to, remember, this is equation 1. So we can say 2, wherever there is x, we substitute with y. What is y? It's equation 2, which is 4x squared. So wherever there is y, we put 4x squared. We can say 4x squared. But let us not forget that equation 1, our y is squared. We can square it there. So from here, guys, we just solve for x. Now, on the left-hand side, we still have x. And then on the right-hand side, outside the bracket, we have 2. Inside the bracket, we have 4 to the power of 2. The 2 that is outside the bracket is going to give us 16. And then we also have x to the power of 2 to the power of 2. That is going to give us x to the power of 4 inside the bracket. On the left-hand side, still we are left with x. And then now we have to remove the bracket by multiplying by this 2. It's going to be 2 multiplied by 16. That is going to give us 32x to the power of 4. Now we can transpose this x to the other side. And then we left with 0 is equaling to 32x to the power of 4 minus x. Right, so on the left-hand side, we still have 0, but on the right-hand side, we can take out the common factor, which is x, and then inside the bracket, we're left with 32x to the power of 3 minus 1. Right, now, if we solve for x, this x here, this one here, we can say x is equaling to 0. And now, inside the bracket, we can transpose this -1 to the other side. We can say 32x cubed is equaling to 1 because we transpose this 1 to the other side. Now, we need to solve for x on this one here. Now, we can say, we can divide by 32 throughout, divide by 32, and then we have x cubed, and then we have 1 over 32. because 32 divided by 32, we're left with x cubed. Now we need to get rid of this x cubed. Let me just do it up here. So we can cube root this x cubed. Let's do it because we are looking for x. So cube root here. There we go. If you cube root here, this is going to give us x, and then this one here is going to give us 0,315. There we go. So this here, guys, is our x on upper limit. So we can say this x here is 0,315. Now that we have the lower limit, which is x is equaling to 0, the upper limit, which is x is equaling to 0,315, we can start calculating for the area. So let me just create a little bit of space here. All right, guys, now that we've created space, let's calculate this area using integration. Now we're going to use sigma. And now we have our upper limit, which is 0,315, our lower limit, which is 0. Do not forget, our limits are x values that we just calculated here. This one here and that one there. Then there's something that I need to inform you about, guys. Now, we have to subtract these graphs. But how do we do that? Now, let's look at this green graph. When you look at the highlighted area here, the green graph is on the top of this one here. It's at the top there. So this basically means that the green graph, which we called it 1, you can say y1 minus y2 dx. So we will be integrating graph 1, which is this one, with graph 2. So we can say this is y1, that is y2, based on what we named them earlier on. Y1, when you look at this enclosed area, is at the top here, guys, while y2 is at the bottom there. So that's the reason why we are subtracting. It means now we need to make y1 be equaling to y. Remember, y1 is x is equaling to 2y squared. Now, if you can make y subject to the formula, we have to divide by 2, and then we have x over 2 is equaling to y squared. But then we don't want y squared. Now I'll continue here. It means now we have to square root both. So if we square root both here, we're going to have the square root of x over 2 is equaling to y. You can rewrite it as x to the power of half over square root of 2. All this is equaling to y. So instead of substituting the original equation, we have to substitute this one because we are integrating with respect to x. So let's continue. I'm going to continue here. Right. The upper limit is 0,315. The lower limit is 0. Now, y1 is going to be x to the power of half divided by the square root of 2. Right. Minus. Now, y2, it's very simple. It's just going to be 4x squared because already y2 is equaling to 4x squared, just in case you don't remember. Then we close bracket, then we say dx. Right. I hope you guys can able to see this. This is a very long question, so I need you guys to brace yourself. So I'm going to create more space, and also I'm going to zoom this one in. Okay. All right, let's continue. Now we need to integrate this. If this is already simplified, let's integrate. So I'm gonna integrate y is equaling to, remember, these are definite integral. So we need to integrate this one, and these are standard integrals. So you can say x to the power of half plus 1 divided by root 2, and then multiply by half plus 1. There we go. Minus 4x2 plus 1 divided by 2 plus 1. Let us not forget. And then the upper limit is going to give us 0,315, and then this is going to be 0. Now let's simplify. Now we know that x to the power of half plus 1 is going to give us 3 over 2. divide by. Now it means we have root 2 multiplied by 3 over 2. There we go, minus. Now we can say 4x to the power of 3 divided by 3. Let us not forget the upper limit, 0, 3, 1, 5, and 0. Right, so let me create more space. Is a y, open bracket, x to the power of 3 over 2 over, we have root 2 multiplied by 3, we're going to have 3 root 2 over 2 minus 4x to the power of 3 over 3. And let's not forget the upper limit, 0, 3150. Right, so let's simplify the first term here. You can put this on a calculator, and then this one is going to give you 2x to the power of 3 over 2 divided by 3 root 2 minus 4x to the power of 3 divided by 3. And then the upper limit, which is 0, 315 and 0. Right, I'm going to continue here. Now that we are done, it's time for us to substitute. Let me just create the space. So when we substitute here, we're going to have y is equal to, open bracket. Let's start with the upper limit. Wherever there is x, we substitute with the upper limit. So it's going to be 2. Wherever there is x, we're going to put 0, 315 to the power of 3 over 2 divided by 3 root 2 minus 4, and then we have 0, 315 to the power of 3 divided by 3. This here is the upper limit minus the lower limit. This time around, wherever there is x, we substitute with the lower limit. We have 2 and then 0 to the power of 3 over 2 divided by 3 root 2 minus 4. Wherever there is x, we put 0 to the power of 3 divided by 3. There we go. So y is going to be, if you use your calculator, what you're going to get here is 0,047 minus, if you go to the second bracket and use the calculator, you're going to have 0. So your final answer is going to be 0,047 unit square. Guys, this is how you do this question here. It was a bit complex. I hope you can see how long it actually took us to do this one. So I'm going to try to zoom it down so that you can see how much of work we did here. I hope you managed to understand this, guys. And if it so happened you didn't understand, do not forget to leave a comment. I will try to answer you to my level best. But to be honest with you guys, this needs you to rewatch it over and over again. And then you can able to understand where you got lost. It's easy to get lost on this question. It was a bit complex, this one. But if you understand that you need to calculate the area using integration, and also you need to find your upper limit and the lower limit, then this question is not that difficult. Remember, your upper limit and the lower limit are based on your intersection. Right. So guys, this is question 5.4.2. Do not forget to like and share this video if this part of the video helped you to understand. And also, guys, do not forget to comment on the comment section. If you haven't subscribed to the channel, subscribe to the channel. We are done with question 5, and also we are done with the whole question paper. So just in case you want to watch the other questions, I will leave the playlist at the end of this video. Click on that playlist so that you can be able to watch the other question papers. All right, guys, I hope this helped you. Thank you very much, guys, for watching. Until next time.